remove the air molecules. So let's say if we have this balloon-like structure hanging from, let's say, a string in this large chamber,
vacuum, and then you release it, and it lets gas out. Yeah, and then it's going to go the other way. Yeah, I mean, it's the same principle as the bullet. I mean, it doesn't matter if what it's expelling is a solid or a liquid or a gas. The only thing that matters is that something is ejecting mass one way. So there's force, there's momentum to eject the mass out one way. So by equal and opposite forces, if Newton's laws are true, then the object ejecting out mass one way has to recoil back the other way.
Yeah. Now Eden, take him back. Listen, I've posted in the side chat and in the live stream there a 15-minute video that totally refutes what he just said. And the guy uses a plastic bottle, right, with some nozzles on the end, okay, and a compressed air, and he pumps that bottle up. It's got wheels on, okay, and it shoots off, right? It shoots off because of material coming out the back. But when they put a toilet roll over the end of the nozzle now and inflate it, it doesn't even move.
Well,
okay,
and
they replace. Hang on, they replace. The toilet. I'm still explaining. They replace the toilet roll with another toilet. Hang on, with another toilet roll with holes in. Okay, with holes drilled into it. They attach it back to that bottle. They inflate it, and the bottle starts to move slowly. So we're demonstrating to you the essentiality of air, how vital it is for rocket propulsion. Okay,
all you're saying is that if you block the nozzle, the thing doesn't work. It's like, if you have to
it's not blocking the nozzle. It's covering the isolating the air all around it. So the nozzle's still there because you can still pump it up, and the material can still come out.
I just posted a debunk of your debunk.
But you're not listening at all because you're just not listening. That's all you're
Sometimes
doing.
People just keep repeating yourself.
Just not listen. You see, when I try to explain something, I'm either monologuing, right? Or I'm rumbling.
Calm down.
Yeah.
Calm down.
Or rambling. You know what I mean? Yeah. So I'm trying to explain. That's all.
No, you're rambling.
10 voices. When I'm talking, 10 voices up here. So can I explain again, please? Right.
No,
here we go.
Please don't.
I'm going to.
I think we should have him go ahead and
with wheels on it.
I have a vote for yes.
Yeah, let's have him re-explain. Start from the top because we might have missed the beginning part.
But thank you so much, ZZ.
Yeah, I'm curious to understand what's going on with the rocket propulsion where you block the nozzle of the rocket or partially obstruct it.
Why do we need Jin to re-explain? He said, in a vacuum, Newton's laws don't apply. It's very simple. That's his point, crystal clear, and I think he's wrong. We all know he's wrong, but at least he's clear about what his point is.
Wait, do we have a video of a balloon? Oh, sorry, an object releasing sort of something, right? Like a pressure or air in a vacuum where it is moving, where it's a constant vacuum. I'm sure there's at least one where it was brought to a low pressure.
The problem with vacuum chambers is there's always going to be a wall. So you can always say that, well, the propulsion is hitting up against the wall, which so the conversation should end. As soon as someone says Newton's laws don't apply in a vacuum, the conversation's over.
Yeah, I'd love to see like a video demonstration of this. I'm sure there's one out there where it's in a large vacuum chamber and they have an object hanging and they're able to keep it in a vacuum state or a low pressure state the entire observation and then open the nozzle to see movement.
If someone thinks that you can sit on a chair with wheels holding a bowling ball in a vacuum chamber and then toss the bowling ball and you won't move at all because it's a vacuum, then like there's no reasoning with that person. Like you think that is just someone who thinks that is clearly unable to understand very simple scientific concepts.
But do we have a video of that? Somebody in a vacuum chamber throwing a bowling ball?
Yeah, I think I have one. I'm joking. It's such a obvious thing that I don't think anyone.
Well, they're breathing, so it puts gas into the chamber, so you're pushing off that gas that they're breathing. So
they're inhaling the vacuum.
Well, no, not they've got a oxygen mask on.
Dang it! You ruined my joke. Good point, though.
You ruined my second joke, but that's fine. Yeah, I mean, like even though we may not have it in a vacuum, I'm a normie, but I trust the people that launch the rockets, that the way they say it works is the way that it actually works, not just random people on Discord.
Yeah, Zizi, have you seen a video? Zizi, have you seen a video of this observation? Maybe like a device or an object in a large chamber where it's an ongoing vacuum or low state of pressure, and then they maybe release the valve and we see movement. I mean, I could try to find the video
like that of people hanging pressurized little like toy rockets in a vacuum, and then it goes forward when it ejects out the back. I haven't looked at one like that in a little while, but I'm sure I could find some.
But none of those vacuum chambers meet the qualifications that Jin stated. He said at 90,000 feet, where it's super low pressure, it's still good enough to have propulsion. But for some reason, it needs to be exactly zero, no molecules at all of air. And that's when Newton's laws stop applying. So I'd like to see a demonstration that he said he had a video in a vacuum chamber. I'm willing to bet that that vacuum chamber still had a little bit of air in it. So his point is, he left, but his point is kind of refuted.
Yeah, Buck, I think there's going to be two scenarios there where it's an ongoing, because the chamber, when you introduce anything, that's no longer the state that it was prior to the start of the observation. So
before
you know what I mean? You would have to have the pumps remaining on while, and then you
understand that before even doing that, you cannot get a vacuum chamber to have no air pressure. It's impossible.
Oh, I see. Yeah. Thank you. Why do you think that is? Is it because the lack of the pump that we're using, or what is it in your opinion?
I mean, I would imagine
the seal.
I don't. Well, even in space, there's still air pressure. No one says there's no air pressure in space. And someone smarter than me could say why it's impossible. But I mean, I imagine that the force needed to hold the vacuum to have no air molecules would be pretty astronomical. But I don't.
Okay, anywho, so back to not talking crazy.
Yeah,
go ahead. But then you'd also have to lie about physics, right? About what could possibly be holding up this.
Eden, he's trying to answer your question and you interrupt. He's answering your question and you interrupt him in the middle of it.
Yeah, if you don't want to answer the question like P. Finky, it's okay. Let's say there's a magic physics and they're hiding it from the populace for whatever reason. Would in your opinion, do you think the government would allow civilians to find it?
What, like the U.S. government?
Sure. Yeah, which government? Which government is it?
Let's start with the superpower, United States.
But and then when you say citizens, when you say citizens, are you talking about U.S. citizens or like all citizens?
Let's start with American citizens. Yeah, you guys are Americans. Let's say you want to set up a rocket, and do you think the government would allow you to find the firmament if there is one? Yes or no?
I've heard the current administration, no, because they're anti-science.
Okay, anyone else? ZZ, I think you said they potentially would let them find it?
No, I said I wouldn't be surprised by the intent of a government to hide all sorts of things. I think my main point was just that, like, I don't understand how it would even be possible unless we're willing to say that there is just this extraordinary level of like one world government control already in place. And I'm sure a lot of people here do believe that. And I'm not even saying that the idea is like in principle crazy to me, but I don't see the evidence of that. Like, I do think that global governments coordinate quite a lot in handshakes between each other to maintain their power over their own citizens, right? Like, they all have a collective interest in maintaining this power. But I also think like wars are real. Like, I do think that global governments have legitimate competition and struggle with each other. So the idea of them managing to not have any leaks to stop every single nation from ever sending up a rocket that exposes this is the part I'm having trouble with.
Okay, can I ask my question now?
The thing is, there are resources, a massive amount of resources. Yeah, of course. Yeah, I was just gonna say there's a massive amount of resources to kind of get to that height of 1,000 miles per se. I mean, Aftershock 2, I think it was only about 144 kilometers, and I think maybe that was about 400,000. So to get to let's say 1,000, we're talking about maybe 4 to 10 million. Mm-hmm. But yeah, I'd love to see an amateur.
My question is this: if
about the nations, quickly, on the nations, right? There might be like some small time competition between nations, but the predating on the smaller ones. It's like lions. Lions will have a little bit of a scrap here and there for girlfriends and territory, but they're not actually going to ever fight each other properly. It's a lot of preparation.
My question is this: if to believe fully in flat Earth, do I have to embrace a worldwide conspiracy where every war that's fought is fake and it's just a coordination between the global ruling powers, or is it possible I can believe in flat Earth and just believe in empirical evidence?
No, you can come in.
Hang on a minute. Let me answer that question quickly. Yeah. Sorry. Go ahead.
I'm making notes, so I wrote that down. Stop being gay.
You're welcome.
Stop being gay.
Yeah.
I got that.
Thank you.
Okay. Anything else? Yeah. Go ahead, Jin.
Yeah, sorry. I just wanted my colleague there, Pure Rigger, to actually answer that in the full, because I know he's got a great answer to that. So please go ahead, and then I'll come after you. Go ahead.
That's what you did? You stopped being gay?
That's a great answer.
I think that's what you need to focus on.
Well, trying at least, you know?
I'm laughing because I thought you had something else, but okay, great. Well, obviously, we flat earthers don't ask you to believe anything. We say that you should go and check for yourself. So it's not relying on all the other conspiracies that are actually happening. If you're interested, you're free to go and check for yourself. Okay. So, and because I happen to mention, 9/11s and moon landings and Pearl Harbor, there's a lot of conspiracies that have gone on, okay, and are continuing to go on. Coronavirus, there's loads, okay. These things actually happen, but they're not relying on you believing. Go ahead.
As stupid and ridiculous as it sounds, right? To stop being gay, it's at least worth trying.
I've got it.
When did you start that process, Chepa?
And tell us the results. What were the results?
Yeah, how did it work, Chepa? How did it work for you?
You got to try everything once, all right?
I can hear my farts again.
Well, do you guys want to debate if it's a
great response, Chepa?
I can hear my farts again now. But anyway, the helium balloon.
Just being gay is choice, or do you think they're born that way?
Okay, so Jin,
that's an interesting question.
You said something that made me wonder, because you said that the conspiracies don't rely on Earth being flat. I was asking the opposite question. Like, can I be a flat earther and just based on evidence, or do I have to believe in conspiracies in order for it to make sense?
You believe in you don't believe anything. You go out to confirm your globe and you end up on a flat earth where you were born on. So it's not a belief.
Why are you guys entertaining the troll questions? I don't understand why you even think that's funny to do.
No, it's okay. The point is there are people listening and that they get a good answer from Jin. The thing is this, though.
Ladies and gentlemen.
The helium balloon, highest altitude reach, 33.4 miles. That record was set in 2002. That's the highest. They don't go to the Kármán line, which is 62 miles, 100 kilometers. No helium balloon has gone that high ever. Okay.
Yeah, you need a hydrogen probably to go even higher.
Yeah.
Okay, so thus far it sounds like the answer is no, or like I can just believe in evidence.
I have a question about the Kármán line.
Yeah, go ahead with the Kármán line question.
Okay, so you believe there's a Kármán line?
Well, no, I don't believe there's one. I haven't been up there to confirm it. I'm going by what's been put out in the public domain. Okay.
there's a lot put out in the public domain that says there's a Kármán
Right.
line.
I don't believe it. Like I told you, I don't do beliefs, but that's the information out there. The highest record is 33.4 miles set in 2002. That's it. They don't go 62 miles up. What's the problem?
I'm just trying to gauge how incredibly intelligent you are.
Oh,
So it
thank
sounds
you
like
very
you're
much.
super intelligent.
Thank you very much indeed. A very live wire is Gen CBR1. Don't touch it. Electric shock.
Thank you, Jen. Pure Rigor, what do you think? Do you think being gay is a choice?
Yeah.
And welcome. Thank you. I agree.
Yeah, 100%. Yeah.
Very
It's
curious.
like choosing
if we
to
were
be
to
Jin.
poll
Like who would want that?
the number of gay flat earthers versus the number of gay anti-flat earthers. We already have like 5 anti in here.
Why are we asking this question?
Yeah. And then can we do a salary next?
All right, if you were gay, who would you do?
That's why.
If you were
I would
gay.
do Icy Spin and West at the same time.
Yep, that's why.
No, Tay, let's say if it is a choice and you're telling people it's not a choice, you're taking away their autonomy to choose. That you might be lying to them by saying you're not making a choice when they really are. So just like anything, people are choosing who they want to be with. So maybe it really is a choice.
I will say if you just judge it based on who brings the topic up more, like who talks about it more.
Quad, King Quad all day. King Quad. There's not even a question.
Yeah.
King Quad for sure.
Where is he to defend himself?
Do you think it's a choice?
Not that he would.
Because people say it isn't a choice. So let's hear the logic. It's not a choice. If someone wants to defend.
I mean, I'm okay talking about Earth, but if you really want to talk about gay people, that's fine. We can do that.
Because
I'm sure there's people in here.
Why do you want to talk about? Love to talk about other guys' junks, and then they say they're not gay.
And I say there's people who disagree. Do you have logic?
What's your fascination with flat Earth, Perfinky?
I like you guys.
Yeah, it's funny. You make me feel smart.
It's not an answer to my question. It's not an answer to my question.
It's kind of like the people that talk bad about the government but are on government assistance. Like
that's still not an answer to my question. Y'all are just skirting my question, I guess. You don't want to answer it.
Rob, let me answer.
Yeah, non sequitur.
Rob, because it's directed at me. You'll notice, like, even if we're talking about topics that aren't flat Earth, I still hang out in here with you guys.
Yeah.
Right.
Well done. Well done.
Still not an answer to my question. Thanks a lot.
I like you.
Yeah.
I like the people here.
I'd like to address the government assistance with the money. Those of you and those people who are listening who are receiving money from the government, it's your birthright, as your families would have paid taxes into the system. Now, they make weapons, poisonous medicines, weapons of mass destruction, and war, and etc. So if the money is going to a human being to help them survive, albeit well done, okay, it's money well spent, okay. Nothing wrong with receiving help when you don't have any money. It's the decent thing to do. Yeah, from your government. Yeah, the government has poisoned you.
Yes. Right. So, like, just private help wouldn't be acceptable. Just government help.
Well, if people want to give private help, go ahead. Those people are out there. Those organizations are out there. Loads of them, all across the flat Earth. So don't knock the money you get from your government.
Let's take, for example, the Lima Agreement, right? Shifting manufacturing. That's resulted in a whole lot of job losses. So, the government sort of, when they're liable for something, they've got to untangle it.
See, roboting for everybody.
Roboting.
It's the most coherent thing I've heard all day.
That happened from my mic. That was a nice change from the fucking nonsense. I was dancing, tapping my shoe. All right, we're resetting. So Earth is a globe, right, Jen?
Absolutely not.
Oh, come on. After all the evidence?
I thought we trained you.
This is fucking, what the?
Like, what are you even here for?
Something earlier.
Absolutely not.
Yeah, just quickly. I mean, you were asking me if I'd ever done the rocket thing in the vacuum myself, and like I am to be clear, very pro all forms of amateur scientific experimentation, regardless of what someone's motivation is. Like, I just think it's cool to test this stuff. But like, I haven't tested everything myself, but if I'm hearing something that just flatly violates the very well tested conservation of momentum principle, like I'm not going to bet much money on it being true, is what I'll say.
Unfortunately, don't hang all your life on the conservation of momentum, because that's crap and that can easily be scrubbed off. That's not the method that I would use.
By who? By accredited scientists or by you?
Thank you, ZZ. You're amazing, bro. Thank you.
Yes, thanks, ZZ.
I got to know why conservation of momentum is bunk.
So good.
My word.
Yes, my word is exactly right.
Okay.
Chepa was smarter than that comment.
Yeah, I think maybe we're trying to say that space is not the same as down here on Earth.
Absolutely not. That's right. That's why
we agree. Space is not the same, but the laws of physics still apply.
So it's not the same. But it doesn't
Newton's law of
exist.
motion cannot apply in the vacuum of space. And
you're the one that said that vacuum. You're the one that said vacuum has no air in it, and that's provably
there's no
false.
air. There is no air in the vacuum of space. There's no air there.
Incorrect.
It's not. No, there's no air there. It's not. Look, you haven't been there. Look, you haven't been there to know anyway. You haven't been there to know anyway, right? And the thing is, humans die instantly in a vacuum. Okay, instantly. So there's no air there.
We've never pulled a vacuum with no air in it.
Unfortunately,
more deadly than gamma rays.
You're being pedantic here now. That's
more deadly than neutron bombs.
Point is, the vacuum of space.
No, you said that we've pulled perfect vacuums.
Okay, now we've got
you were wrong about that, Jin.
And film being destroyed in a vacuum chamber. Okay, the Apollo detectives put some film, the film that NASA said they took to the moon.
They didn't. No, they didn't.
They did.
It wasn't their same film.
They put it in a vacuum chamber.
It was not the same film.
Yes, they did. 10 to the minus.
No, it wasn't.
You keep saying no, but they did.
About vacuums.
10 to the minus.
And he just admitted that vacuums have air in it by saying 10 to the minus 13. He doesn't even know what he's talking about.
I do know what I'm talking about.
While he's saying there's air in it when he says 10 to the minus. Jin, please stop interrupting me. Jin, please stop
interrupting.
You're
interrupting me. I was speaking.
No, I didn't.
I could hear your voice. I could hear your voice while I was talking. No, I hadn't
You just said
I hadn't finished, right? And you just kept interrupting.
No, you
Jen hasn't really talked a lot.
You interject.
Jen said very
Jen,
little.
I'll give you more floor.
Yeah, Jen's going to oppress. If anybody here is going to oppress, it's Jen.
Yeah, let's blow geeks. Let's hear it, please.
I have a question
Jin,
for
you said that vacuums have no air in it, and then you just said that the vacuum that destroyed it was 10 to the minus 13. You realize that it means it has molecules in it, right? Gas molecules, right?
They can't pull a perfect vacuum, but the residue, 1 or 2, 3 molecules doesn't constitute anything that's going to help the film. The majority of the 99.9999999% of the air has been removed. So basically, you could almost say it's devoid of air, right? And the film in that vacuum chamber was destroyed, and it wasn't at the level at which they would have encountered had they gone to space. Okay, this was only 10 to the minus 3 tour, right? And the film was destroyed within 3 days.
So that's not what SC says.
Doesn't matter. The point is he was given the film. Okay.
Real quick, I want to just let everyone know something. I just posted a PDF last night. I was having a pretty interesting, in-depth discussion about my interest in seeing how far I can get to rederive a lot of the results of relativity theory without taking the initial assumptions of it. So I just posted that as a PDF because people were asking me questions I couldn't quite answer without the document in front of me, and I called it Relativity Without Relativity because the idea is if we drop the postulates of relativity, assume that there is an objective stationary reference frame, how far just using the mechanics of electromagnetism and the latency of light can we rebuild to the same conclusions that are cited as predictions of the theory of relativity?
That's
coming
super
for
sick.
Ru Young Wang.
Who said that?
XX.
Who said it? Can
Sorry,
you
ZZ. Yes, just I posted.
Can you email or just DM me? I wanna talk to you.
Yeah, sure. Just message me.
He's the Crunk debunk.
I'm the two galaxies in my profile. zzpop 10.
Oh, there you are.
Yeah.
All right.
Yeah, so what's this relativity without relativity? What?
Yes.
That sounds like an oxymoron.
No. So
it
the point,
does.
Yeah, I mean, kind of intentionally so. But the
like
point
acting without
is,
acting.
The point is that there's a standard derivation of predictions of relativity, and my interest in this is, can I get back to those same end results explicitly, though, while rejecting the core postulate of relativity. So everything I'm doing is in a framework in which there's an objective stationary, there's an objective definition of velocity. So there's no changes of reference frame at any single point in any of my work, and no assertion that it even would be legitimate to change reference frames. So it's purely what can be shown just based on the rules of electromagnetism and the signal delay of just the timing signal of light. If you're looking at something from far away, there's a signal delay of light coming at you if a light flash is released. That's all. So those are the only things I put into the analysis, but I'm looking to reconstruct many of the end results that are attributed to the theory of relativity, but from purely relativistic physics.
Well, you can't have stationary in your model.
Well, this isn't relativity. The whole point is this is stationary. It is absolute stationary. That's the whole point of this, is can I rebuild to experimental results that are attributed.
But what's your independent variable? No, I'm just kidding. Go ahead.
So what he's trying to do is he's trying to steelman ether, essentially.
Hmm?
I mean, it wouldn't necessarily be ether, but trying to steelman the claims, at least a large chunk of the claims that are made by the ether cosmologists.
No, but you guys, in your model, there is no such thing as stationary. Everything is moving.
Everything's relative.
I'm stationary right now
and not listening.
Yeah, no, but this isn't relativity. That's the whole point. I'm specifically, you'll see in the first slide here, I cross out the postulate of the equality of reference frames. I establish that there's one stationary reference frame. That will be the only reference frame I do anything in. There's an objective, correct measure of time and measure of velocity as measured by the stationary reference frame. And I'm simply looking at in careful detail what actually happens to electronic objects as they move within the stationary reference frame. And
put
what
it another way,
yeah,
he's doing what you would do, SE, if you did the math. If you could do the math.
Okay, he's starting off with the assumption of a stationary relation.
Very simple addition and multiplication is the only math involved.
I think I understand what you're saying now. You're starting off with a stationary reference frame.
Yep.
Okay,
and never leaving it. Never leaving it, never rejecting it, holding to the starting axiom that there is a true stationary reference frame, there is a true objective rate of time for that stationary reference frame, and that there is a true definition of the velocity of an object as measured. At no point do I do a reference frame shift. At no point do I legitimize the idea that the world would look equally valid from a different perspective. I'm sticking strictly to one perspective. You could call it the ether perspective. But I'm looking.
Oh boy, Einstein would be mad at you. Holy moly.
Not really.
Not really, because I'm looking to see if the path Einstein took to get to some various conclusions missed some things, missed that there were things Einstein assumed that maybe weren't necessary to assume, right? So Einstein gets the prediction about moving clocks, that moving clocks tick slower. He attributes that to the postulate of time arising from the invariance of the speed of light and the legitimacy of all reference frames. And what I'm attempting to show here, at least with one simple example, is that there's actually a mechanical electromagnetic reason why a clock in motion would tick slower. within a objective reference frame ether type framework.
And what would that be? What would the mechanism be?
The balance of the electromagnetic forces between its components.
But how so? Due to movement? Due to
yes. Yes. So I'm taking the standard pre-relativistic Maxwell equations of the electric force and the magnetic force, and looking at creating a simple clock device of two charges moving around each other. Well, in one case, one of them's stationary and the other one's moving around it. In the other case, they're both moving together. And the point is that when they're both moving, there are different forces between them. There are magnetic forces between them while they're in motion that are not present when they were stationary. So that physically changes how quickly they move around each other.
Oh, I see. You're attributing a magnetic force due to movement.
Yes.
Yeah, because both elements are charged, right? The clock is charged and whatever's orbiting is charged. Yeah.
Yeah, so, the clock is basically a little atom, but you don't need to think of it as an atom specifically. It's a positive object and a negative object, and we put the negative object doing circles around the positive object, like a ball on a string that you're whipping in circles. Okay, if it was on a string, the center pulling force is the tension of the string. Here it's the electrical attraction between the two of them. But you put the whole thing in motion, now there's magnetic forces that interfere.
Unfortunately, there's no such thing as negative charge. Sorry to break the news to you guys.
Oh, you done got dice low.
Please, everyone.
Watch out.
Just saying, I mean, there's no such thing as negative charge. I mean, they're scrambling to even define charge, let alone negative charge. I mean, it's.
Well, I lay out what definition
I'm with you
super clearly.
What's charge?
I say right at the very beginning, we observe that objects can attract or repel. We call that property charge, and because we observe that sometimes things attract and sometimes things repel, we're going to name some things positive and
just
some
let him
negative.
finish.
That's it.
Yeah, no, that's called polarity. That's what you're talking about is polarity, and that has nothing to do with positive and negative charge.
Yeah, you could rename it whatever you like. We could call it.
It's not renaming; it's what it is. I mean, the only things we see attracting is a magnetic function. I mean, you guys can talk about positive and negative and gravity and all these other things, but unfortunately, the only thing that we can empirically decipher to have this attractive and repulsive nature would be a magnetic field, more accurately, polarity.
Okay, well, I can clip two things of tinfoil up to electrical wires and they attract or repel, depending on.
Yeah, that's because an electric field has a magnetic field simultaneously in conjunction with it. So anytime you have an electric field, there's always going to be a magnetic component, and there's always going to be a push and pull. We could see this with charged wires. They'll either push apart or pull next to each other, depending on what's going on. This is all a magnetic component.
We need some set of words to name things. So I'm using conventional sets of words. It wouldn't really matter that much. We could have called it.
Yeah, it's not the word.
Any
it's
words
not the
that
word.
we want.
It's the explanation behind the word.
There are things that attract and repel each other. I'm going to give names to those things.
I mean, you can call it what you want, but at the end of the day, it's the explanation behind the words, right? And when the explanation doesn't fit, regardless of the word you choose to call it, it's just wrong.
Let's move past this. Let me ask a clarifying question. Dyslow, would you agree that when you say we call it polarity, would you what is the mechanism? Like what is intrinsic in that, that concept of polarity? Like, is it that opposites attract or is it something different?
Yeah, it's something different. There's actually no attraction. I know you guys love using that word. But unfortunately, particles don't have sentience. There's no such thing as attraction. Misnomer.
Well, we don't mean it. I don't think we mean it in like the fall in love sense.
Yeah.
Well, obviously, you guys are talking about it like two things coming closer together. You're calling it attraction, but that doesn't really get into the causal mechanism as to why these two things are coming closer together.
It is a force that is exerted on both of them, pulling them together. Yes, that's attraction. That is literally the definition.
Not how that works, Omnivore. It's not how that works. See, a force is not a thing, Omnivore. I hate to break the news to you, but a force is what something does. So when you're calling it a force and simultaneously calling it attraction at the same time, you're literally talking about two actions taking place. A force is not a thing. Say it with me. A force is what something does.
Okay, but I'm not trying to say that I know or am ready to provide the ultimate answer for why these forces exist. I'm just purely going off of the surface level observation of we see things stick or repel away from each other, so let's name them something and point out a couple basic observations about what they do, and then I track how to build a really simplistic model of a clock using two of these things. And I just look at what happens to them according to the known tested rules of how these things work. And you're right, there probably is a much deeper layer explanation to it that's not relevant to the thing I'm trying to show, which is purely focused on just the observable mechanics at a surface level that we see, regardless of what the deeper causal reason is that these forces exist.
I mean, you're just literally talking to talk then at that point, because I mean, if you're not going to get down to the brass tacks here, then we're just literally ascribing words with nothing to support it.
He's describing
again,
a potential experiment.
Then yeah, look, my purpose was not to offer up an explanation of what the deepest root reason for the existence of electromagnetism was. It was just to look at a very simple clock setup operating under the known rules for electromagnetic forces and to see if I could recreate the time dilation effect without the use of the postulates of relativity. That was the purpose of this.
Okay. All right. Well, I'll let you say what you got to say then. I won't interrupt you.
No, that was it.
So this is a great piece of work, zzpop. I really like this.
Thank you. Yes, I'm still manning the ether position.
I think that there's not going to be. I think you could show this to ether cosmology, and they couldn't tell you. They couldn't begin to guess what's if there's anything incorrect with it.
You mentioned last night the challenge of actually measuring it, but if it is an LC circuit, my intuition is that we could measure how it detunes as it's in motion.
You mean it might change? You mean that the force might change as it's in motion?
That's the predicted output based on what I understood him to say last night.
I'm not listening. Yes. No, hush your mouth.
Yeah, so first of all, I didn't do out the full LC circuit one because I needed to tone it down to something that would be much simpler, but it's the same principle here of just the one charge going around the other rather than the full circuit. The full circuit's much more practically easy to build, but would just take longer to go through the derivation of all the components of it. And this was simpler, so easier to do as a kind of theoretical walkthrough. So yeah, so I addressed that. You get to a point within this in which you think for sure that this is showing the existence of an objective speedometer, right? That this very basic analysis of the electromagnetic forces shows that this thing, the charge going around the other charge, cycles slower if the whole thing is in motion. So it's like, okay, then clearly that's going to give us an objective way to determine if something is or is not in linear motion. But then you got to read the rest of it there, because then what I actually look at is the case of two clocks. They both start off synced, and one of them moves ahead of the other, like it's on a train, I don't know. And they both agree to release a flash of light when their time reads 1. Each clock is agreeing, okay, when I tick to 1, I release a flash of light. And then I look at when the other clock actually receives the flash of light. And something very interesting happens there, that you actually get a total symmetry of when each clock is receiving the signal that the other clock has ticked once in comparison to its own recording of time.
I mean, I got an easier answer. You take two clocks, two cesium atom clocks, and you separate them apart in different locations. There's going to be a difference. There's going to be a difference. I never said that atoms weren't real. I said the atomic model's wrong. Thank you very much. But point is there's going to be a difference across the surface. You're going to have different magnetic effects. You're going to have different weights. I mean, to assume that everything is just even keeled across the surface, whether it be longitudinal or latitudinal displacements, you're going to have a difference. And that difference is going to register on something so sensitive as a single cesium atom. So just saying.
Well, maybe, but this is, in principle, what I've done is they wouldn't have to be separated out a very far distance at all, just that one was moving, compared to the other. So in principle, the distance could be extremely small. If you've got one on one end of a table and another shot across the table, all that mattered was
let me
one
ask you
was
this.
moving, one wasn't.
Let me ask you this. Do you agree that weight changes depending on where you're at, location specific? So if you weigh something in one spot, and you go to a complete another spot, far enough away, you're going to get a different weight. Do you agree with that?
Just using an elevator, yes, absolutely.
I'm asking ZZ. I just want.
No,
thank you for confirming.
I haven't tested that myself, but I agree that that's what is said, and
well,
I
it
don't
is
have
said,
a reason to doubt that.
So
Not
let me
that
ask
I've
you
tested
this.
it myself. Yeah.
So if there was a different weight measurement depending on the object not changing, would that affect the cesium atom? If we're to agree that weight changes and weight is location specific,
Well,
would the
I really
cesium
don't
atom be
know any
affected?
reason why that would affect it. Like
Well, that's
why
what I'm asking. I don't.
No, because the cesium atom for the effect is like too small. When it comes to our weight changing, let's say when you use an elevator or you go to India or etc., where there's different gravitational potentials, it's a very small percentage of your weight. And since like you're in kilograms, let's say 120 kilograms, you might like be weighing 121 kilograms after the elevator ride or something like that. But that one kilogram is not a whole 1 kilogram. You're probably at like 120.8 kilograms, and you gained 0.8 kilograms, 0.2 kilograms to reach 121.
Well, maybe we should try to break it down to a percentage.
A cesium atom isn't weighing 100
dude?
kilograms, so the ratio and proportion of the mass gravity is basically negligible on that scale.
Well, here's the thing. It only takes a single ounce. This is why we have a thing called a troy ounce, and generally, gold is supposed to be weighted at a specific location. Jin, you're hot miking for the last 20 minutes. Gold is supposed to be measured at a specific location, right? So that everybody can be on the same page for obvious reasons.
How much?
So if a single ounce, if a single ounce is going to show enough weight change to the point where it's going to affect dollars, I would assume that a single cesium atom is going to have a weight difference as well, being that it has mass, does it not?
Well, a single ounce gets, let's say, basically 0.005 grams. So if you add that up to a kilogram, that's 16 ounces. So you do that times 16, so 0.005 times 16.
Kilogram is not 16
and you're
ounces.
still in
a pound is 16 ounces.
Factors. But yes, our tools is able to measure that difference in grams. They do measure that very easily. Even micrograms. We have microgram specific tools. So yes, we can record this over an ounce.
Okay, but that's not my question. You're just kind of like hijacking my question into something else.
No, I'm actually addressing
that's fine. That's fine. I'll take it up with someone else at another time.
So let me ask ZZ Top something here. So first of all, you wrote that paper, Relativity, not Relativity?
Yeah, I've been I was working on some other stuff and then got distracted into working on this today. So while you guys were chatting about stuff, I wrote this up over the last couple hours.
Okay. The next question is, this clock that you say is moving, right?
Mm-hmm.
Now you're saying that the speed, the movement of it is causing the slowdown of it.
Yes.
In relation to what? Is it causing like the magnetic thing? How is that caused? And is it moving? I think you said an ether or something?
Yeah. So So if you pull up to, I guess these aren't numbered. That's too bad. So there's a particular slide in which I show, and this is just an observable thing that we can test, that if you put electricity through two wires next to each other and the current's flowing the same way, the wires attract, and if the current's flowing in opposite directions, the wires repel. All right, experimental observation here. Well, that's motion of charge down the wire. So what type of motion are we talking about here? So I'm working off of a framework where I say, like, yeah, there's an objective stationary reference frame. There's an ether. There's, something like that. And that is the objective standard of motion. So the magnetic force between these things depends on how fast they're moving, how fast compared to
So hold on. Let me interrupt.
Reference frame.
So the clock in reference to the ether is that motion is causing the magnetism. Is that
yes? The magnetic force. Yes.
Okay. All right.
What did he say was causing a magnetic force?
The motion of the
motion, the clock relative to the ether.
Clock relative to the ether. Well, that's the thing is magnetic fields like aren't necessarily emitted from a magnet. Like this is another misnomer. The magnetic field is already there. The magnet is affecting the already present magnetic field, creating a sink, so to speak.
Yeah, so let's call the magnetic field a property of the ether. And when something is moving, when a charge is moving through the ether, it whips up the magnetic field around it. So we've got this clear objective difference between stationary versus moving. Stationary charge doesn't disturb the magnetic field, moving charge does. So
the moving charge is going to create what's called gyromagnetic precession, to be most precise, which is essentially field friction, or we could call it magnetic torque.
So just to be clear, there's a couple different magnetisms we could get out of a charge based on either its linear motion or its rotational motion. Both magnetism, both motion, that whips up the magnetic field. And the gyromagnetic precession has to do with something that is spinning, that is rotating, the particular type of magnetic field of a rotating charge. These are not rotating. I should have said that. I'm keeping this strictly to simple.
Oh, it's just pendulating back and forth?
No, just linear motion, just straight line motion. Yep.
I'm surprised that particularly Omni and your baller brethren are not all over you just for the mere mention of ether. I'm surprised they're all quiet and stuff. What's up, guys?
I mean, they've got their own ether, SE. They just call it quantum foam, and then
but they're quiet. Dicelo, they're suspiciously quiet.
ZZ Tops sounds like he's got his shit together. So I mean, I don't know. They're probably intimidated.
These topics I'm interested in. I don't think that ether is the main thing for most people debating here. Most of the debates are about the curvature of the Earth, and the ether thing is kind of a secondary thing. And yeah, I have a particular interest in this type of stuff, like the fundamental nature of the universe. It's more interesting to me than the shape of the Earth, frankly. So that's why I'm on about this.
I'll send you some videos, ZZ. You might find them interesting.
Sure.
I assure you, ZZ, if a flat earther in here came up with that idea, they would be up in arms. They would be blowing their stack right now.
Well, I've said this before. You know that I do think that, especially when we get to topics of cosmology and space-time, the nature of space and time, the nature of matter, the nature of fields, that the broader physics community is stuck on certain orthodoxies of thought, of how they believe is the right way of viewing and interpreting and explaining these ideas, and I differ significantly from my fellow professional physicist on how I think about these things.
The mainstream understands field geometry, but they don't understand field dynamics. That's like where they really need to get it together and get in tune with what's going on.
Well, I must say I don't necessarily agree with you, but I'm kind of impressed with you thinking out of the box. So good on you for that, ZZ.
Yeah, I'm frustrated by how relativity is taught and presented and conceptualized and sort of rigidified in the sort of orthodoxies of thought about it. I respect the experimental findings. I also think that there's always room for debates about interpretation. And I think it's important to debate interpretation because even if two different interpretations agree on the experimental facts, they don't disagree on anything that is testably different. I think it matters to humans doing science to think seriously and worry about how clear our conceptualizations are. Like I don't find it sufficient for the mainstream physicists to say, well, we know the equations of general relativity work out in a particular way given these experiments, so if you don't get the interpretation, that's a you problem. Like I don't like that. I don't buy that. I think it's very much a collective problem if large numbers of people in and out of the field have serious reservations and difficulties with sort of the conceptual baggage that is being pushed alongside these theories, and it means there isn't enough openness to different frameworks of interpretation of the data.
Why do you think that is?
I struggle. You want to go, Daislaw?
Yeah, I just wanted to ask him why he thinks that is. Like, what is his thought behind, the fact that there's just a huge disconnect and in terms of like trying to openly discuss these things, and
well, you can.
Seems to be some sort of prejudice. Huh?
You can. I'm not saying it's sort of a grandiose conspiracy and that like I'm going to get killed for talking outside the mainstream language choice of a physics textbook. I would just say academia is a corporation. It's a job for people, and there are career.
Oh, so you're not referring to this community. You're saying like at large.
Sorry, I thought you were asking me. I was speaking critically about what I see as the rigidity of the mainstream physics community. I was speaking critically about that, and I thought you were asking me why I think they have those rigidities. Were you asking me something else?
Well, I was just going to say, just imagine you had a one-on-one with DMOC, and DMOC was absolutely sold. He memorized everything that you said, and then he came to this room and then started to share these thoughts. I don't think it would be met with such, or be receptive.
That
perhaps,
would require DMOC to actually listen to what he says.
Oh, sorry. Yeah. So the question was then, why do I think that this particular community has, I don't know. I mean, I see here a lot of people who are willing to go debate things on the edges of what mainstream society debates. I mean, even if people get kind of aggressive with each other and try to shut each other down, like there's a willingness to keep coming back and keep engaging no matter what. So I don't know. I don't know what brings anyone else here. I can only say I'm brought here because I find it interesting to listen in on all these conversations. Yeah,
I was just saying,
give each other a more fair shake, I guess. Like don't jump down each other's throats quickly. That's my message to all.
Thank you, ZZ. I second that.
Is it muy fácil?
Was that a hot mic?
I think that was Jake.
Almost sound like elbow.
Jake, are you hot micing or you wanted to get in?
No, I didn't say anything.
That's what I thought.
Your mom?
Yeah, bitch.
You should make it your mom.
Takes one to know one still.
I was just trying to extend Daislow's thoughts into verbalizing it.
Thank you. You definitely took the words out of my mouth.
I nailed it.
So ZZ, I'm curious your opinion because yesterday we got into dark matter, and I was trying to explain to forgot who it was, and it wasn't getting through. Few people that they literally just made up dark matter because they got gravity wrong when they witnessed spiral galaxies, so on and so forth. What's your take on that?
Yeah, I could give a quick take on that. And I do want to say, someone said, commented that I was trying to steelman the ether position, and the answer is yes. Like, even though I think that the Earth is round and moving through space, like I'm not interested. I'm interested in the steel manning of the ability to observe the same observations and fit it to a different model based on different assumptions. Just wanted to kind of, yes, agree that that's where my head is at as far as what's interesting here to me. Anyway, so the dark matter thing is that, I'm stepping into sticky territory here because I'm going to have to immediately start with heliocentrism and everything, but just, know that whatever you believe about it, like, this is, what the mainstream debate is and how we got to this point. So starting with heliocentrism and Einstein's general relativity and the Earth going around the sun, there is an observational match between the equations of general relativity and the orbits of the planets. The equations of general relativity can fit the orbits of the planets as observed, and they do so a little better than Newton's equations. Newton's equations almost got it. Einstein's equations fit the solar system better. Okay, then
So
you zoom
does
out. Yeah, I was going to just
does
to
his
explain it. Sorry,
May I
yeah.
interject one thing?
No, let him finish. He was
Because I need
getting
to get
a
up to
good
dark
part.
matter. So then you zoom out to the galaxy and you look at how quickly the stars in the galaxy are spiraling around the galactic center, and they do a similar calculation. And now it's hazier a bit as to how they're estimating what the mass of the galaxy is supposed to be, but we think we know stars. We think we know how star brightness and color relates to their mass. So you look at the galaxy's brightness and color, and you come up with like a ballpark estimate of how massive it should be. All right, now you look at the stars orbiting around the galaxy. They're going way too fast, just way, way, way too fast, like 5 times too fast by the outer rim of the galaxy. So the first thought people had was maybe we've just vastly undercounted the mass of a galaxy. We're only counting the stars. What if there's just a lot more stuff that doesn't give off light? Gas and dust and maybe very dim stars. But like one by one, those things got eliminated. So now they're down to the point where if the reason a galaxy is spinning as fast as it's spinning is because there's all this extra unaccounted for mass in the center of the galaxy, it can't be a normal type of matter we already know about. That's been eliminated by process of elimination. So it's got to be something else, and that's what they call dark matter. And the only thing we know about dark matter in the model is that it produces gravity, and it could be anything. And it can't interact with normal matter, otherwise we would have seen it and felt it already. So
Wrong.
we would be swimming in
It can interact with matter, just not with light.
Well, but the point is that detectors made of matter haven't found anything.
So, I mean, why couldn't it be just like a centripetal force at hand, like literally,
Because of what I clarified yesterday to SC Montreal.
I'm asking ZZ, bro.
Well, the centripetal force is just anything that keeps something going in a circle, and there's no tether holding stars to the center of the galaxy. So the only known force would be the gravitational attraction to the center.
Polarity, dude. Magnetism, that is the tether. It's like a dog being staked, or with a leash on it being staked in the ground, and as it processes, it starts coming closer and closer together. To the point where
don't think there's enough magnetic force to do that. Otherwise,
yesterday, SC Montreal brought up the same thing and same lie in the same question at the same time.
Dude, don't start calling people liars, bro.
Let me finish. I clarified specifically that there was no like getting gravity wrong and therefore making up dark matter to account for it, which is SC Montreal's argument. And I clarified specifically that there was like a gravitational lensing. They detect gravity and there's no matter, so it doesn't interact with light, just like pretty much what zzpop said, except for that you made the mistake of saying it doesn't interact with matter. It remains matter.
It hasn't been detected to, is the thing. Like, every detector that's tried to find, like, if it exists, then theoretically we're swimming in it right now. There's a big cloud of it all throughout the galaxy. Like, going by gravity, going by gravitational lensing, the visible galaxy that we see should be within a much bigger cloud of this stuff. So it should be all around us. And even if it doesn't react with light, you're right, maybe it could react with matter, except every experiment to actually detect one using something other than light, using like nuclear like reaction sensitive material to try to like catch a dark matter particle maybe interacting with the center of the atom, has failed. It's all been null results. So if it does exist, not only does it not interact with light, but it doesn't interact with matter by any known mechanism, to such an extreme degree of non-interactivity that our most sensitive things, that don't just detect light, but detect other things, weak nuclear and strong nuclear forces.
That is correct. They say they cannot detect it, but this is the funny part. It has to interact with matter in order for it to make the galaxy, the spiral galaxy, do what it's supposed to do according to gravity. Well, so it's like a dialetheism. They need it to interact with matter, but they cannot detect it. So it's a made up thing. It's plain and simple.
So to be clear, when I say it doesn't interact with matter, I don't mean the whole point of it is that it would interact via gravity. I was meaning like direct collision.
Yeah.
Just to clarify here, what they're saying dark matter is something that generates gravity, but is both invisible to light and has no collision forces with matter. So if it exists, it's passing right through us, not stopping for anything. No interaction.
An oxymoron.
Yeah. I mean, you realize these people are still looking for the graviton particle, right? Like, these are the same people that presumed sound to be comprised of a particle emission that they called a phonon.
Yes.
Like, they've got wild, wacky ideas, dude, that they will never put down, and they'll pursue it to time immemorial, dude. Like, they're not going to stop.
I like the phonon. It's a pulse of sound.
But it's ridiculous. That's not how sound works. We know that now.
Oh, sound's a wave.
Phonon is no.
Okay.
Oh, sound. I mean, a wave isn't a thing. Let's just start off with that, regardless of what the dictionary says about it being a noun. But no, sound is a vibrational disturbance in the medium.
Okay. Yes.
That doesn't have a speed. Doesn't have a speed. Sound doesn't travel. There's nothing physically moving from A to B. It's a rate of induction that propagates through the medium.
There's a propagation speed. I mean, you could still use the word speed.
Yeah. Well, again, speed infers something physically moving from A to B. Like, the accurate way to define it would be a rate of propagation.
Okay, the propagation rate.
Yeah.
Yes, sounds of vibration with a propagation rate through a medium.
Correct.
Phonon.
Correct. Because you start saying speed, then you got people thinking that phonons exist, dude, because they're atomist, and to them everything is surely a bumping particle. I mean, it couldn't just be field interactions. It's got to be a bumping particle.
I feel like there's a hang up over the word particle, and that a lot of people think that particle necessarily implies like a little billiard ball thing. But when I hear phonon, I just think of, yes, a vibration, not a noun, not a new object. Yes, just a propagating vibration in a medium, but
well, that's because you're smart.
Of minimal amplitude.
That's because you're smart, but unfortunately, no. That's literally what they're saying. They're describing it as some sort of a physical piece of matter at a very obviously small unit of matter, and it has mass, and yeah, and it bumps into other particles. This is what they believe.
Well, yes and no. Yes and no. They believe it's two things. They believe it could be a wave. It could be. They also believe it's a field, and when it gets disturbed, like they believe in a whole bunch of nonsense.
Well, they've never defined a field. Yeah. They just talk about energy points in a set proximity, but that's not a definition of a field. We know fields exist. We know fields aren't comprised of particles, and in their worldview, anything that exists is comprised of a particle.
So that's a real debate, and this is a real debate, and it's where I think interpretations of physics matter, as far as there's two different ways of looking at where quantum theory is at. One of which is the field first way of looking at it, the other is the particle first way of looking at it. Under the particle first way of looking at it, that's fundamentally an atomist view that reality is made of discrete little bits of things. They come first. And what we call fields is a kind of approximation of their collective behavior. In the way that you might say temperature is a field. It is the collective energy of all the vibrating air molecules, but the air molecules come first, and they're all little, pre-existing solid objects. And in the field first way of looking at it, you would have to say that the field does fundamentally exist, meaning it's a real physical substance. It's not just a mathematical abstraction. There is a true medium, right? This is where we touch back on the concepts of ether. And the particles are just stabilized vibrations within it. Not objects in a classical sense, but just localized regions of vibrating energy in an underlying fundamental medium, and that underlying fundamental medium is not made of particles.
That's kind of what I think. That's kind of what we're talking about on the ether side, right? And
yes,
an atom is literally just a dynamo.
I find the concepts of people who are pro-ether align to an extent with my very much field-first way of thinking about quantum physics, in that the particles are not the fundamental thing. They're just local vibrations. The field is the fundamental thing. And if we're going to say that, then that means we actually have to now get serious about the field as a real physical substance, a real physical medium. We can't just hide away and call it a, made up mathematical abstraction.
Yeah, that's the thing, is it's non-physical, it's non-quantifiable, and this is why the debate's still going on, because nobody can empirically validate the ether on its own, because the ether on its own is at a complete, rest, equilibrium, inertial state, right? It's only when it's perturbed where you get this vibrational effect taking place, right? And that's where we get into light, electricity, magnetism. So again, the ether on its own, right, is non-quantifiable, cannot empirically validate it. It's more of like a logical framework that remains consistent with the field interactions, being light, electricity, and magnetism, all three being one and the same thing, only different due to their pressure mediations of that field.
I think you could put it maybe this way. How could we definitively, experimentally detect the fundamental thing that all things are made of, including ourselves, including the measurement devices? That can get a little bit
well, we can stretch things past what the device should measure. And if we could see, an effect taking place, that should tell you something, that there's more beyond to what you're measuring.
Right.
And there is an experiment for that.
I guess what I would say is that the way I would think about it is that it's a framework. There's always multiple possible interpretations of the data. So I would just think of it as that maybe at a certain point, as science progresses, it will become clear that one particular framework is the most helpful one, the one that most succinctly grounds all possible.
I think the most helpful one that would completely refute relativity would be instantaneous action at a distance, because that violates c. It's actually faster than c. Like, I forget by how much. It's significant, but
I don't know of any examples of that, though.
Yeah, well, there are examples of it. I can send some stuff to you, but this is what.
Okay.
Yeah, it's what Einstein was calling spooky action at a distance.
You mean
yeah, so that's what quantum kind of infers to on entanglement, but this is actually like sending, a signal at long distances that's receivable, not like some sort of little electron S or P wave spin. Like, this is usable, and it's non-lossy, meaning you can send large amounts of power and literally pipe it through without any loss. This has been proven multiple times. This is what's spoken of in terms of longitudinal versus transverse wave propagation.
I think he's talking about like superliminal
propagation. No,
nobody's ever
superluminal. That's like Chernikov radiation. That's faster than luminal velocity. But I'm talking about c, faster than the speed of light in a vacuum.
Like in the vacuum. Yeah, I don't know of anything that can transmit anything faster than light in a vacuum, but by all means, post stuff.
And there's nothing.
Yeah,
there's no evidence that anybody's sent information faster than the speed of light.
Well, you guys just haven't been given the gravy, I guess. That's all. But that's fine. I'm letting you know it's there.
So where can we find it?
I mean, you're talking about you'd be the richest man in the world if you had just cracked that, but.
Well, I mean, it's not me, dude. I'm just telling you what's been done multiple times by multiple people.
The evidence would be
just let him talk and let him tell us.
I think he's talking about non-Euclidean light travel. Is that right?
I'm talking about scalar wave technology. I'm talking about being able to send.
I do appreciate how we're really getting back to basics here. The Flat Earth side is taking us back to the simple, concrete things we can all see and feel with our own hands, like superliminal technology.
Well, Tesla claimed he had such a
device, horizon,
but I don't think it's ever been produced.
That was his death ray that he spoke of. But yeah,
it's been done multiple times. It's lossless. Like who did it and how do we see it being done?
Eric Dollard's got some videos on it.
I'd like to see.
What's that?
Where's Eric Dollard's multi-billion-dollar company who's cracked this amazing new technology?
I mean, he worked for RCA for quite some time and did, I don't know, some stuff for some pretty large companies. But now he's on his own doing his own thing. I don't know, like, I know you don't want this to be a thing, right? Because it completely refutes your model outright.
No,
it's it's a death blow to relativity.
I actually don't care. I don't care that much about relativity. If instantaneous like transmission of internet packets would be awesome.
Yeah, I would.
So many things you could do with
zero latency internet, dude. That'd be like the best thing ever. You could game anywhere. It'd be like no problem.
There's a lot more you can do with it, dude. This is like literally a multi faceted weapons platform. Essentially,
dude, you could build
it's not only receiving, but it transmits. And I don't know. We've got some whistleblowers coming out of Raytheon.
So you said somebody did it. Who? So Eric Dollard, did he claim to do this? He claimed to send faster than light, zero latency information transfer.
Yep.
Where like, all right, I'll see if I can find that.
Eric Dollard is legit, and he's also verbally outspoken against flat Earth, by the way. So go Eric Dollard.
So someone posted a video that is really cool that, as I recall, I think was about entanglement and some of these effects that show a correlation in the behavior of particles at long distances. And it's interesting. There's something to dig into there. There may be some sense in which the universe is interconnected with itself over these long ranges, but it is critical to note that it's not possible to use this as a telephone, that no one has devised any way to use entanglement to input a message on one side and have it come out on the other side.
They actually got some new technology where they're able to pipe sound through light coherently. Cool. Like they can literally pop a sphere up like at a random location, let's just say, and pipe sound through it.
Still light speed, but that's cool.
Very cool. Yeah, pretty weird, but
I'll pick this up. I think I gotta go at the moment, but pick it up again sometime. Peace.
All right. See what you did, SE?
So how do we explain opposite polar circumpolar star rotations?
How did we get to that?
I bet Eric Dollard could explain that.
I sensed a 9-second delay, which means new topic. So, pardon me.
Yeah, he's got some videos on the sun that I haven't dived into yet. I'm curious what he has to say about that.
Eric Dollard, you said?
Yeah.
I was about to post a patent of Tesla claiming that he surpassed the speed of light. I'll post it in a second.
Dude, even just like people that trade stocks, like automated stock trading scripts, you could corner the market if you had faster than light communication.
And he would, like, if that was true, then Tesla would be like the richest man.
Not to
like,
mention the
ever
fact
born
that
on
your
Earth.
trades could go back in time.
Deal with him. He would have made like a deal. He'd be the richest guy
Your
on Earth.
your mic sounds muffled, bro.
Yeah, you got something in your headphones.
Yeah, you got something in your mouth or something for sure. You can try again if you want.
I'm sick of your lies, Die Slow. My microphone is clear.
There it is.
Oh, no, Tanks is still here. Okay, maybe he can explain it.
So I posted one of the patents. Now I don't know if it's true or not, but I recalled reading that about Tesla. There it is right there.
There's patented perpetual motion machines too.
Yeah. And interferometer accelerometers.
Like for example, this photo here, Sigma Octantis, the rotation is clockwise, right? And then Polaris is counterclockwise. Just can't figure out, like I've thought about this for at least like 17 seconds. And then I took a little bit more time, like I don't know, 6 or 7 seconds to decide whether or not to bring it up. And here we are.
You've never seen the dual pole flat Earth map?
What you're saying is you did not think it through.
How long did it take you to begin the thought?
Jesus, I have no idea. I didn't consider that when I started thinking.
Yeah, so it was. I'm just saying, like, was it because you're mixing the two things? Was it instantaneous or did it take time to begin?
It was objectively, it was like at least a couple seconds. But do you have an explanation, No Tanks?
So you're off the whole like delay because it was instant, or
yeah, that's fair. Delay? I'm off. Yeah. Do you have an explanation though for this image I pulled off of Facebook.com/photo and then a bunch of numbers?
I do. Yeah, it would be incoherent. Yeah.
Oh, it's incoherent. Okay. Was that Rakia that spoke up? Thank you, Rakia. Give me your best college try.
Yeah. I can show you optical illusions that happen 5 feet away, much less 5,000 miles away. I can show you an object going through a medium that looks like it's going left to right. It actually is going right to left.
Well, with all due respect, can you explain the photograph that I dropped in chat there?
No, but that pretty much explains all things that you don't seem possible, like observations. To be fair, I'm driving, so I can't view it, but I'm saying in general, anything that you can't explain, right? If I showed you a arrow in a medium going left to right, and you didn't know any different, you would say it's going left to right when it's actually going right to left in reality.
Is it an optical illusion, or can you measure it going left to right while it's actually going right to left?
You can just look at it.
He's talking about the cup,
looking
like the
and the human. Wait a second. Looking and the human mind recognizing something like seeing faces where there are no faces, seeing something bigger where it's actually smaller. This is an illusion. Like the eyes got tricked or your brain got tricked. But if you measure it, if you measure it,
about like
you see the truth. And
yeah, if you measure it going east to west,
air,
that's a measurement. That's the truth. And if you see it doing the opposite, you know that it's an illusion.
Yeah, he's probably talking about looking at a store. He's probably talking about like looking at a store window and seeing the car drive behind him in the window and going, "Oh, look! It looks like it's going right to left, but it's really going left to right."
No, he's talking about the glass of water. There's a glass of water thing where there's an arrow behind it, and then you move the glass in and out, and it like flips the direction of the arrow. My take's more like these aren't there's every day we go out in the world and we see things and we accept them for what they are, and we don't, like, if we see a car, we just say, oh, the car's right over there. We don't need to come up with another explanation of how the car is like behind us or to the side of us or whatever. That's a little bit what it's like for me with the Southern Star Trails. It's not that it's a perplexing observation. There's a simple explanation that works every time perfectly, which is that we live on a globe. It's only perplexing if you're committed to the idea that Earth is flat.
Yeah, and measurable. That's what I mean. Like, you can actually measure the motion and the position of stars, and you can predict it, and it will exactly be there. It's not an illusion. That's the difference between an illusion where your mind got tricked and something that you can actually measure.
Your mind's definitely getting tricked, bro.
You can't prove if it's an illusion or not. That's the whole point. So if you lived on a sphere where the Earth rotation and the whatever you're talking about, you would have other factors that would be easily done also. And, because they're not, we try and come up with alternative explanations. And another easy one to come up with you can do in your kitchen is introduce a medium where it tricks your brain, right? You wouldn't know it unless you did it yourself or someone showed you. And that's the same thing. And it's 5 feet away, not 5,000 miles. So to say you can't be fooled, right? That's lying to yourself. Of course you can be fooled. You could definitely be wrong.
Yeah, I think you're arguing against a point nobody made.
It's kind of like saying, well, if you can be fooled that a magician is sawing a woman in half, there's no way to know whether a woman is actually sawn in half or not.
Fool me once, shame on you. Fool me twice, well, that ain't gonna happen.
Listen, I went to a David Copperfield act, and this is what happens, right? They only hire twins. When the people on the stage disappear, the people behind you are their fucking twins, and they're wearing the same thing.
Hey, Globe guys, we did the whole.
Hey, wait a second. Acknowledge what I said.
Like
it was important.
No, for like 3 or 4 hours, we did the whole troll thing. So it just respond now.
Yeah, I did with my anecdote that you can figure out things to not get fooled, right? Easy.
Yeah, we're not talking about magic tricks though. We're talking about how the brain perceives something, right? And you can't prove or disprove it. In magic tricks, you can be behind the scenes and all that, but what I'm saying is you can't be behind the scenes of maybe this medium change or whatever's causing this possible illusion. I mean, I was just asked how I would explain something like an error.
Except we have ontology and epistemology to solve that problem.
I don't know who that is clipping in, but it's probably one of the.
He was responding. Yeah, don't interrupt. Let Rakia finish.
I don't even know where I was, but I guess the point is,
I just like to cut you off.
Yeah, I don't mind. I mean, it's part of it, but it's usually the same people. But the optical illusions that I've seen just today, right, on YouTube, and that I can go home and recreate are amazing, right? So to say, and that
medium.
Go ahead. Sorry.
Oh, I was actually sort of speaking up for Omni, but I think you said something about the medium. Can you go back to that? You said like we are fooled by the medium. What do you mean by that?
Well, in the case of what he was talking about, the glass filled with water, it's a medium change that I think, and like an angle of the round glass with water in it that causes that optical phenomena to happen at close range. But there's other illusions. Like today, I saw one on YouTube. Yeah, I'll finish this real quick.
Okay, go ahead.
Today, I saw one with a slight angle, right? Two guys standing on a platform that was slightly angled. And when the much taller man stood on the one side, he looked shorter than the man, that was actually the one shorter. And when they moved, he looked like a giant next to the guy, right? When they switched positions, it was just an angle change. So, yeah, and that's at close range, right? That's at 10 feet away. So that's what I'm talking about.
Well, yeah. Do you think that this illusion with the giant appearing next to the man after a series of steps or whatever, do you think that effect can be quantified by people that are smart?
well, I think we can figure out why it happens, and you can measure it when you can get to, like, you can measure the heights of those two men because you can touch them, feel them, all that. But there's other circumstances where you're looking through the atmosphere or looking out into the night sky or whatever that you're not going to be able to do that.
So you would agree that like smart people can quantify it, I think, but like it sounds like you were kind of jumping to what you think my next argument was, but like, do you agree with what I was saying?
I don't care what your arguments are. So you're wrong about that. But yeah, I think smart people have figured that out.
Yeah. So do you think that we can? That's fine. Do you think that we can quantify like things like just refraction in general and come up with explanations that make sense?
To a certain extent, and when you apply it to like certain parameters that fit certain things, you get biased and you forget that it might not fit all situations. And when we're talking about looking long distance through an atmosphere that's forever changing by the second, and then applying what we would say refraction does and call it standard through a vacuum, I think we get confused. I think people are smart enough to figure out that that's not talking about, you know, you can't apply standard refraction to looking 10 miles through the atmosphere every time. Like, it's just not possible. I've proven that. I have videos that prove that. You can go out one day and have similar conditions and it looks clear and get this, or it looks cloudy or not clear and you get that, and go back the next time it looks clear and you get something different. I mean, it's just forever changing.
So do you agree that
I would just like to add, hang on, I would just like to add that every definition of refraction you guys bring up requires two mediums. And I'm yet to find a definition of refraction that has only one medium. Thank you,
Rob. I appreciate that. Hold on one second.
Will set you up. Fermat's principle will set you up, Rob, and also no, refraction does not require two mediums. A gradient
show me a definition.
Rakia, hold on a second. Hold on a second. I was
go ahead.
Give me 1 second. Yeah, Rakia, do you agree this photo I showed you like 5.5 months ago is good evidence of the horizon curving in the distance?
Sure. I have many myself, so sure. I don't remember your exact photo, but
it's the photo from Ibiza with the two red. They're sitting on the table, and you were talking about how the legs were part of the experiment.
Okay, I know sure. Yeah.
I can jog your memory. It was very. We were talking about these two known straight edges on a green table, and the known straight edges show the horizon in the middle. Okay, yeah. And you were saying that when I asked you to explain why the horizon is bending in between these two red straight edges, you said, "Well, the actual table isn't sitting on a level surface, and it's like, in fact, it's like sitting on rocks." And it's like kind of like on a rocky ledge. Like, you'll recall it when you look at it when you aren't driving.
But it's been used for 10 years. Yeah.
Yeah. Is that still your position, that the rocky ledge has something to do with the photo and with the observation in between the two known straight edges?
I've never said anything about a rocky ledge causing any effect. I think the photo you're talking about is a lens effect. That's why the table, that once you compress it or whatever they do with that photo, it looks curved, and the atmosphere looks curved also, where you shouldn't see left or right. Even in y'all's own model, you shouldn't see left or right earth curve.
Okay, so I just dropped the compression that you're talking about, and I know you're driving, but maybe when you get to a red light, someone else can speak. You can show me where in between the observation area the red known straight edges are curved, and where the horizon, maybe you could go a step further and explain why the horizon is most definitely curving in the background.
Yeah, so I actually took a piece of yarn to my screen, and I measured those red things to be straight. While the horizon in between them is curved.
These guys are fucking hilarious.
I remember when you debated what was it, Blitz and Peter Markley? Yeah, that was great.
Oh, I totally posted them.
Yeah, you pwned them. But yeah, seriously though, like I mean, just someone can look at this image, and I bring it up to Jeremy's distaste, maybe even Gio's distaste. I bring it up from time to time. It's been a while, but 5 after the hour, scroll up, you'll see a very, very obvious curve. Grizzle might even pop up on this one. She was talking about it last time, but I cannot explain that. I just can't.
Yo, let's go back to fucking 2023, okay? Since the flat earthers are stuck in the past, let's bring out the past. I challenge any flat earther
I thought
here.
flat Earth was dead.
Listen
Why
to
are you
this.
even bringing it up?
Listen to this
Dude,
victim.
Flat
just
Earth
let him
is
talk.
dead. Remember?
Listen to this victim. Poor
Yeah, go
guy.
ahead.
You're
Fucking
so
idiot.
lost.
Where's your map?
Listen, hey, I challenge any flat earther in here, come up with a better flat earth model that I,
Where's your map?
on my own,
You guys
realized.
hate my flat Earth model.
Listen to this
Makes you
retard
all fucking
spiral.
jealous.
Listen to him. Listen to him.
Rob's dating the
Yeah,
model,
listen
dude.
to me. You guys
Listen
hate
to
my
you, Rob.
model.
Hey,
It
by
makes
the way,
your manliness feel bad.
we'll let you spiral, bud. Are you done? As I was saying, every one of you motherfuckers in here, I challenge every flat earther, any non-dual pole flat earther, because I've been pushing this shit as the ultimate
So you
flat
want
earth
a
model.
model.
Are you
Get
done?
fucked.
Are you done spiraling, you fucking retard? Anyways,
Yeah, you're the fucking retard.
Let's relax. Let's relax, guys. Rob, let him finish.
Every fucking day.
All right, thanks, SC. Rob's muted on my
Extra
end.
pump of vanilla and
I
extra
challenge
hot. I didn't hear that.
any flat earther in here. I will literally get into the mud and dirt with you. I have a better flat earth model than you. I will prove it. I will demonstrate it. I will model it. Excuse me, I've already modeled it. Ladies and gentlemen, I would like to pose as the pinnacle flat earther in this room. If you think you've got a better flat earth model than me, test me. I will challenge you. I will challenge you in the most unbiased, fair.
Let me summarize.
Go ahead.
Gatebreaker is going to mud wrestle flat earthers to show them the correct model. Is that right?
Of the flat earth, because he's a fucking retard.
No, not at all, actually.
I'll record that.
All right, sorry.
If any of them would come out with
what
an
you're saying is you have a
actual
better,
model,
you have a better model, right?
Hey, you know what? I'm
I
tired
straw
of
manned you on purpose. You know,
I have the best
reaching
flat
my
earth
hand to these
model.
flat earthers. Let's have some fun, Globers. Back in 2022, I remember I would join this server, and at the bottom of my heart, I would try to get 30 seconds to talk. I would try to get 30 seconds to talk about this dual pole model, but you know what these cocksuckers in here would do? They would mute me so they could hear Witsit back in 2022 run his mouth for 4 hours. Witsit can't save you. No one can save. Hey, flat earthers.
Which is going to come back and save us.
Hey,
I feel like you're watching the World Cup, dude, and you've just been on a drinking bench for the last 2 days.
Stop interrupting me. Flat earthers, I am Eric Dubai. I am your flat earth god. Hey, if you disagree, give me a better flat earth model than the one that I will shit on you on. I am the flat earther.
Why are you demanding a model
I've
if you
got
can't
the
provide a model
You
yourself?
fucking
I've got the experience.
I
Not
want to know.
only do I
I want to
talk
see
the
his model.
talk, but I will walk the walk.
Give your keys. Give your keys to somebody else, and don't leave the house.
Any flat earther who got utterly triggered by these words, come at me. I got models. For you.
All right.
Come at me. Thank you
You
very
got
much,
bottles.
ladies and
We
gentlemen.
got bottles. We heard you. Plenty of
I
bottles.
don't need to come at you because Witch is going to come back. Witch is coming back, and he's going to school you. He's going to show you. Witch is going to show you all.
Hey, no tanks. You don't even respect
He's coming
Diceflow.
back.
Why are you
coming back.
sucking his asshole? You don't even respect him. You don't respect
Oh,
Diceflow.
he never promised to save me the way that Witch is going to save me.
Stop sucking up his ass.
He called them and told them they shot it and they fixed it, but he needs me to send them back to point
All
out.
right.
Well, Gatebreaker, I mean,
Hey,
that was
Earth, your height. Earth is life, you're hot miking.
Dude, I want to see his
somebody
model.
unmuted
actually
you.
giving commentary about Gatebreaker, I think.
Look what you do with it.
You got thanks.
I was just saying that like B-ball gets unmuted, and this is what he does with it. He hot mics. He's got crying babies. It's just waste.
Wait,
what a
what?
waste.
No, that was
the baby's coming from Earth
I
is
didn't know
Life.
Gatebreaker was his son.
Yeah, that's Earth is life is B-ball. B-ball for
to be
life. Earth
fair,
is life.
I'm not a big fan of Octavio. I would like to have the Gatebreaker name back. I can deal with change or whatever. But yeah, nobody explained the curve in the background of the well, Rakia said that it looks like a lens effect that's compressed.
Well, listen, it
of course,
has
that doesn't
to
make
be.
any sense.
No, the lens effect is only affecting the in between the red things.
Right,
It's
exactly.
CGI.
The globe has got this here.
That's the only answer.
Ah, CGI.
Yep.
Well,
Your
listen,
girlfriend
it has to
CGI,
be.
bro.
I would imagine it has to be some kind of a lens effect, because otherwise, what you would be implicitly proposing is that if an observer, as you can see, when there was another guy, he set up an observation, a similar observation, but he did them back to back to back to back, like all next to each other. You can see it in the
what
in
about
the
this
text chat.
observation then?
So what you would be implicitly
yeah, but what about this observation though, where there's like straight
that must be
edges
it. That must be the end. That must be the end of my statement. You're right. What about this one? Yep.
Well, you're addressing a straw man right now, right?
No, I'm not. So
you are.
What you
You're
must be
actually
implicit.
literally
Somebody mute this
addressing a
guy.
straw man.
Can somebody mute this guy and Omni? Because just ahead of time, get ahead of it.
Because he's saying the truth that I'm straw manning him. Please mute him.
All right, great. So, like, what the person will be implicitly proposing is that if an observer were to move, 5 feet to the right, that they would have a separate sagitta, and the Earth would be curving down to the observer to the left of them, and that would be incoherent and impossible. So there must be another explanation, unless you believe that that's the kind of world that you live on.
So what about this observation though? That was great.
Oh, do you concede, or do you believe that is what you would expect on some kind of weird shaped Earth?
I'm actually indifferent, but what do you think about my
Okay,
photograph?
all right. Well, listen, we can't. That is your photograph. So your photograph.
Did you post that in the live stream? I see.
Yeah. So what you're doing?
What I'll do is I'm going to copy image, post image
just out of
again.
control. I'm going to just put my headset.
The ADHD, that is no tanks.
Just hit play. Just let it play all day or something like
that.
There you
go.
go.
Meta tanks. I put it at the bottom there,
Christian radio or something. I'll just put
literally the first thing.
You gotta go one at a time, guys. Come on.
Just turn it on and just let it play. I'll just let it play.
Tanks, did you hear my? This is a side tangent, but did you hear my Jin versus Rob slowed and reverb track?
No, I did not. But while I was viewing this, proof, I guess, by IC Spin, the guy who sees spin, what that would have implied that all observers would have their own, their own little hump there. It would be higher in the middle, and then lower on the ends. But so now it would only follow from his photographic evidence that if I were to set up that same demonstration right at the end of to the right or the left of that demonstration, that then I would see a point that was higher in my middle, and his would be lower. Is that what you're proposing?
Yeah, well said. That's well said. Thank you.
Everybody's on top of the ball, all at the same time, right? Fucking retards.
There's no change. Wait, there's no. Are you guys? Like I see spin? Are you proposing that that wouldn't be the case? Because if that wouldn't be the case, it would be entailed that all those points are at the same elevation. Is that kind of what is that what you're leaning towards?
Well, I'll be brief, right? I posted a photo. I asked for an explanation of why the horizon was bending in the background when the known straight edges weren't. And you said a bunch of other stuff about a straw man, about someone else's observation, blah, 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 blah.
Yeah, you're asking what it is. I'm wondering what it can't, like what, let's do like a process of elimination. Let's see what it can't be. Like what it can't be.
Why don't you just propose
I don't think it's a cow.
Like what it can't be on the, with whatever it is you're proposing is it can't be that 2 observers, then 3 observers, then 4 observers all lined up in a row have their, highest point at the same point as all the other guys. Is that the kind of world that you're talking about, where everybody has the highest point? No.
Not to mention the fact that you should see land. You shouldn't see it end at water, by the way, right? Because land is beyond whatever this ocean is. But let's ignore that. Let's just talk about the curvature.
Let's please ignore it. Yeah.
I mean, that's a flat Earth killer right there. You should see it.
I don't know. It's just
disappear
you're
into
just
the
jumping.
haze.
Do you want to conclude on your picture, or do you want to go to a different picture? That's
No,
not
I
what
want you to conclude on my picture. That's been the whole fucking thing. Conclude on my picture.
All right. So
why is
so
there a curved surface against known straight edges?
Yes. So knock it off, right? And stop changing to like land or whatever it is that you're.
I'm off knocking. Go ahead.
Are you Are you proposing that all observers to the left, right, everybody? We set up. This is a repeatable. This is science. This is a repeatable demonstration. Is that correct? Let me answer that first.
Obviously.
Okay, so if I repeat this demonstration at the exact same time as that initial observer, whoever's taking a picture of the red sticks, would they have a similar or the same result?
I mean, from that vantage point, right? If they use the same lens, the conditions are similar. Sure, they'll have similar results.
Yeah, everything exactly the same. So I'm gonna now, if we line up 5 observers, we're all 5 of us. We're gonna do the same scientific experiment. Now, are we all going to observe a different sagitta or the same one?
We're all going to see the same photo, and we're going to be able to compress it and show the same.
No, it's not going to be the same photo. It's going to be a different guy performing the same experiment, if that's what you want to call it.
Yeah. So what's your point? Yeah. What's your point? Why is there a curved?
Are they all going to?
Wait. Cut the shit. Why is there a curved background? Just explain.
You're bricked. I can't help you. You're bricked.
Literally, all I asked you was why is the background curving against known straight edges? You want to ask me everything but that.
What he's trying to say is that because people lined up next to each other, they all have their own hump, which for some reason sounds wrong to him. It's just like
right. It sounds right. That is the truth, or that's false. I mean, that's you guys know that in your mouth.
Hey, Icy Spin, any flat Earth questions, direct them my way. I've actually built models on this shit. These guys are they're role playing. Ask me, I will let you know. I will literally let you know the best possible fucking explanation a flat Earther can give to this.
I didn't think someone could be more annoying than Demo.
Let me lay it out. I'm going to lay it out for you, Gatebreaker, very simply. Gatebreaker, are you aware of the photograph that I dropped at 13 after the hour, we'll say? Yes.
I see it now.
Yep. Okay, cool. There's known straight edges in this photo, and that are the red apparatus, which we're having a viewport, right? There's a curved horizon in the background. Can you explain why that happens?
From a flat Earth perspective?
From any perspective, from reality.
I'm not, actually, I am a flat Earther. Let me be a flat Earther
Ask him any question. Ask him anything.
Hold on. Flat Earther speaking, what's the altitude of that fucking camp? Hey, I'm adopting the flat Earth.
Why are you LARPing as a flat Earther?
Shut up, retard! Meters. I'm talking to Icy Spin. Icy Spin. What's the altitude
guys.
of the camera?
Stop with the retards, both of you.
I think it was 83 meters. I can double check.
83 meters. 83 meters is what, like 300 feet or less?
Mm-hmm.
Yeah. Well, I've got high altitude balloon footage that I could share you at 100,000 feet. You just said what? How much again? I forgot already. How much again?
I see what you're saying. So you're just not going to answer the question. No.
You're cognizing at my revelation to you that the Earth is flat. There is high altitude.
Feet.
Why are you interrupting? There is high altitude balloon footage at 100 plus thousand feet.
I love you, Gabe.
With a 360 cam, by the way, which has the whole 360 around. That doesn't show what that image shows. So we're calling fake on that image. Try again.
Okay, I'm gonna input
absolutely. Hold on a second. You fucking nailed it. All right, go ahead, Mike. Excuse me. Thank you.
So the 100,000 foot that I'm assuming you're talking about the little piggy. That is incredibly barrel distorted. And notice that the horizon never goes above the center of the frame, causing the convex to concave a bit to look flat.
Bro, don't give examples, bro. Don't make claims. You're a flat earther. All you got to do is deny the globe. If you make claims, the globe's
okay. I'm not done. Okay, I'm not done. Also, that picture that Icy Spin provided, that is a wide view angle is a very large picture, but is scrunched down to be very small so that we can see the curvature.
I have got the metadata to prove you otherwise, sir. What are you going to say to that when I produce it?
The Earth's curvature is not literally that much at that altitude.
How do you know?
2 words, icy spin.
How do I know? By comparing it at verified, legitimate, official footage at higher altitudes.
You understand.
Curve.
You understand the picture is squished, correct? What you're seeing is miles and miles and miles squished into one little picture.
Yeah. I could load a picture in my fucking image editor and squish that shit. Yeah.
Yeah, exactly. That's what was done with
where I come from.
When
you squish a picture like that, we call it optical buffoonery.
Wait. Let's wreck these globers again as flat earthers. Globers, ballers.
This fucking place has become
how
so
high is that?
fucking-
How high is that? A reference frame again? How high is that reference frame?
What does it matter when you're like? It doesn't matter how high.
Shut up. Icy spin. How high is that reference frame again?
I'm getting you the metadata exactly right now. I think it was 600 feet.
Yeah, well,
it was an iPhone SE.
600 feet. That's nothing, bud. We flat earthers, we get on planes 30,000 feet in the fucking sky, and the horizon ain't dropping like that. I look left, I look right. I don't see that. That's some image foolery right there. Try again, Globers.
Is this
try
no
again,
tanks?
Globers. Welcome to Flat Earth.
This is Gatebreaker. Holy shit! I thought this was no tanks the whole time.
Are you also
no question.
Taking a
the
picture?
Earth is flat. When I'm in an airplane,
He's watching you guys. Turned into a troll fest.
Listen to these Globers interrupt.
You gotta chill out.
When you're in a plane, when you're in a plane, are you taking a
great skit? I love this.
Wait, is he really? Wait, is he really?
Gatebreaker is posturing as a real flat earther. And
you forgot to say bro.
God damn, you got me, man. You got me.
Dude, it was so good, right?
That was fantastic.
Dude, that's what I'm saying.
This is beautiful.
Thank you, Gatebreaker.
Good job, Gatebreaker.
Yeah, that's exactly what Tanks did. So yeah, I mean, I've got the metadata. I'm gonna post it in a sec. I just got to redact my.
Well, you guys had no rebuttal. You kind of flat smacked you guys.
Oh God, who is that? Is that
flat earthers? Take notes. When the heat turns up on the Globers, they want to play it's fictional.
That's right.
Oh my God!
You forgot to say moderator.
Ryan.
Are you guys all in the same room and been drinking or something?
No.
That would be fun.
It's a Monday. I don't drink on Mondays.
Bro, listen, it would be like a fucking bachelor party if we were all in the same room right now.
Yeah, dude, there'd be strippers. We wouldn't be here.
There would not be a light that was still working. We would have busted all of them.
Listen to this Glover spiral. You flat earthers, you heard that? We asked them for some evidence. They don't provide it and they laugh. Welcome to Flat Earth.
Fucking
Globbers. Go, bro.
He's great.
Deal.
Gatebreaker, you're freaking great.
Listen to these guys.
For that metadata, bro. Laugh and then
you guys don't have any rebuttal to any of the points he's bringing up, so
I just dropped some metadata, bro.
Yeah, you ought to be banned for that. That's spam right there.
Metadata is not going to save you. I see.
I'll tell you what. I know. I'll tell you what. I'll drop some.
Look. There's about what 50 lines of spam in that. Where in that show?
Look, I'll make it look better. Good point, though. There you go. It's a code block now. Is that better?
Hey, IC Spin. Can I ask you a question on this?
Yeah, hit me, Gio.
So let's say for a moment, there are some other arguments as to why that has a curved effect when you compress it. But even if we just leave all that aside for a moment, let's just say that there is a curve just for the discussion. What do you expect, meaning that kind of bowed-looking effect, it kind of looks bowed, on a planar Earth that is very large and very extended, and you can only see a limited region, like a circle around you, sort of like a hula hoop, idea. You put a hula hoop on the floor, and your circle of the Earth, like the extended plane would be much larger, but you only see a portion of it. So you're basically looking at a circle around you of a limited circle on a larger plane Earth. What would you expect that horizon to look like? Would you expect it to look perfectly flat and a straight line, or would you would you consider it like a hula hoop or on a flat plane to have a little bit of left to right curvature, but that curvature is not Earth curve, but would just be the circle of vision on a planar Earth. So what would you expect to see? And then have you considered that factor? And how have you isolated for one or the other?
Personally, okay. Well, I'll try to answer the second question. That's a little bit trickier. But the first question is, what would I expect on a planar Earth? What I would expect is for it to be relatively um, straight and not curved in the background, and then I would expect that it would sort of like fade into the distance and that almost non-curvature, and to the point where there would sort of be a blurring effect between the sky and the ground. I don't expect to really see land. I think that it would likely haze before it got to that point because of the atmospheric um issues that you're going to experience over water. Like it's just sort of unreasonable. Like when people say, "Hey, can you see Paris from New York?" Like, why can't you see it? I don't think that you would even get close to that on a flat Earth. I think that it would haze, sort of like imagine like the Loch Ness monster, right? And like that scene in like I don't know, an Aesop's fable that talks about it or whatever the fuck, wherever it was produced.
Question your
Like where
reality,
it's just
bro. You sound like
where
a
it's a bunch
blogger.
of like just fog, right? Like it would fade into the fog sort of and it would
You have any
never
evidence?
obstruct
Any
bottom up.
resources? Links on
Yeah,
that?
you're
All
right.
right, so
Gabe
you're
Breaker.
expecting. So to try to clarify what you're saying, you would expect to see a perfectly flat line that is hazy,
I didn't say that, but continue.
fuzzy. So
I said that it would probably be a variation because there are waves. I would expect it to not be perfectly straight, but maybe to the naked eye, sure. And then it would just sort of fade, right? Like it would just sort of I mean it wouldn't be really much more distinct from this photo because when you compress it, right, you get a lot of artifacts and a lot of like straight up and down lines. If you're looking at the compressed image,
We've
it's
lost you,
not
bud.
like a
Honestly,
clear
we've
photo.
lost you. No one's
The
believing
point
but
is that
let's
it would
just,
be straight. It wouldn't be curved.
all right, so let's say the planar Earth is infinite, just for the moment. So you're on an infinite plane. You obviously are only going to see a portion of it circle around you. So you're telling me that circle of your vision, as far as the light can travel and as far as you can see on the ground, that would look like a straight line, even though it's like a hula hoop, a curved hula hoop around you, sitting on the
At
ground
this altitude, yes, it should be straight, right? Like it's like, what did I say, 83 meters? I think I dropped the metadata so we can double check that. It's probably different, but it's not
why
high
would a
enough. I've actually
circle?
researched this.
Why would a circle on a plane look like a line?
It depends on your altitude, right? Like you'd have to be much higher on a flat Earth for there to be any
Well, yeah, if you
any
take a
distinction.
hula hoop and you put it at your eye level, like around your head at your eye level, it will look straight. But if you lower it, a half an inch, it'll look very slightly curved. If you lower it a whole foot, it'll look very curved. You put it all the way on the ground, on the flat
This is the thing
ground,
though, it's like
it'll look
what you're
very
saying
curved.
right now, but what you're saying when you make this statement, Geo, is and it sounds like it's a what if statement, but like you're sort of proposing that Earth does take on a definite shape that is a hula hoop, right? Like
No,
when
I'm
you're
just talking
asserting
about
this.
the vision around you. I'm not saying the Earth has that. Just the circle of how far you can see would be like a radius, basically. Now I
The
know there's
problem
going
is
to be
that you
conditions.
asserted
You're going
an
to have some,
infinite plane model, right?
yeah, but
Infinite
if you have
plane,
an
you
right, but
shouldn't.
if you have an infinite plane, you can only see 5 miles on that day, and you have a 5 mile radius of a circle that you can see, 5 mile radius circle of the ground that you can on, let's say, an infinite plane. I'm not saying the Earth is an infinite plane. I'm just saying that for the moment. So you're only seeing 5 miles of it, a 5 mile radius of an infinite plane, which is a circle. So why wouldn't that potentially have some of that left to right curvature? And then in effect looking to it. But is that curvature of a circle on a plane or on a globe? And keep in mind, on a globe, even if it was a globe, when you went up at altitude, when you're looking at the horizon, if you were to plot all those points on the horizon on a globe, those would be like a hula hoop. So those
This
all
is what I
sit
mean.
on a. So hold
I
on,
mean
let
to
me
cut
finish
you
what I'm
off.
saying. On a globe Earth, let me finish what I'm saying. On a globe Earth, all of the points on the horizon are sitting on a plane. Even on the globe, they're all sitting on a plane. So any left to right curvature that's even claimed on a globe would also be an effect of a hula hoop circle because all of those points, if you stuck a hula hoop on the side of a ball, all those points are coplanar, even on a globe.
Listen, I can't fathom a concept of why is a hula hoop even a thing on an infinite plane, number one? Do you care to answer that?
Yeah, because you would have a limited distance you can see. If the plane is infinite, you're not going to see infinite amount of land. You're going to see 5 miles, 8 miles, and that's a radius from your eyeball to the horizon. So that would be
But
a
why
circle.
would it be a hula hoop? Why wouldn't it just be straight across, like of just disappearing?
Because the sun
nothingness?
is a sphere.
Because the hula hoop is just a description of a circle, like a radius. Because if you're on a massive plane, you can only see 5 miles of it, left, right, back, forward, in all directions. Then,
but what I'm saying is, why would your vision? Why would your vision from your vantage point create a circle around you? Why wouldn't it just be flat, disappearing nothingness like we would expect?
Well, because there would be a limit in all directions of how far you can see, or not. You can't see infinitely.
Yeah.
Now the radius it might vary a little bit. Maybe it's 5 miles off to your left, it's 4 miles off to your right, because there's some clouds or different visibility. I'm not saying it would be like an exact perfect 5 mile radius, but you're going to see in some kind of a limited circle on a massive plane. You can only take in so much of the distance until the ground meets the sky. Sometimes it's 5 miles, 10 miles on very rare occasion. You know, what the world record is like 305 miles, I think now is the record. So that's like the maximum. So yeah, you're just seeing in a circle. But the thing is, on a globe, again, even if you were on a globe and you're looking at the horizon, you're just referencing the horizon, all of those points, if you plotted them around you 360 degrees, those all sit on a coplanar circle, even on a globe. This is why globe earthers like Zanuck. This is why globe earthers like Zanuck now agree that any curved effect from high altitude is not validation of a curved Earth. You're actually just seeing
Gio, what is your conclusion? What is your
on both models.
effect?
Let me just finish the last thing. On both models, you're seeing like a hula hoop circle. The only difference is that on a globe, from your feet to the horizon, there would be curvature, allegedly, but that's not what you're referencing when you're just looking at the horizon. Like you're posting. So they're the same.
Snooze, let me hand it off to you, Snooze. Snooze, let me hand it off to you with a question to you, Snooze. My explanation about the horizon and it bending through the frames, like, and the fact that it what I would expect on a flat Earth for it to be kind of sort of fading into the nothingness as a flat image through these, and no matter how we look at it, does that make sense? And am I off the mark, or is Gio asking the right question, or what? Can you help with that?
So I agree with you on a flat Earth. It was just fade out. Like
he didn't say anything. He didn't counter Gio though. He didn't. Icy Spin said nothing.
Gatebreaker, can you briefly just?
I can't answer.
Just wait a second.
That's why I'm handing it off.
I agree with you, Gio, that the horizon, basically every point on the horizon, assuming like on water, no topography or so, is on that hula hoop. I don't really get your idea of the implications, like therefore, because it's basically all on one plane, we shouldn't see left to right curvature. Is that what you kind of conclude out of that situation?
No, it would be potentially like, let's say you have a hula hoop and you put it on a flat Earth and you look around. You're seeing, if you're above that hula hoop, you could see. Well, hold on. I'm just saying, on a flat Earth with a hula hoop around you, you would see some left to right curvature effect. It doesn't mean the ground is curving, but you're seeing, just like a hula hoop can look curved left to right, flat hula hoop that you're above. Now on a globe Earth, it's the same thing. You're above a flat hula hoop that is just on a ball. So the point is that any left to right curvature effect on a flat Earth or a globe are both caused by a hula hoop, which is a coplanar circle, on both models. So it is not just because there's a curved effect at some times, some altitudes, is not isolation or exclusivity to the Earth being curved. They're both a coplanar circle of hula hoop. Now, again, there would be curvature on a globe from your feet to the horizon. So yes, but that's another topic. That's a dropping from,
So wait a second. I was not done. Wait a second. You can continue soon.
I have a question.
The one thing is on a globe, you are, as you correctly mentioned, you are above that hula hoop. So, like if you put the hula hoop on the ground and you stand on top of that hula hoop, you see the left to right curvature of the hula hoop, even so it is on a plane, right? Because you're looking down. And let's assume we are on a flat Earth and you lie down a hula hoop, you still see the left and right curvature of the hula hoop. However, this is not the horizon. So on a flat Earth, you may have a circle that is, I don't know, 30 miles around you, all the same distance. The thing is, that 30 miles around you circle is not the horizon on a flat Earth. However, on a globe Earth, you can put that hula hoop on a ball and you can find a position in the room above this hula hoop where the hula hoop is exactly pointing the horizon of that ball. And that's the difference.
Wrong.
All right, well, let me, hold
No.
on, bro.
There's even a better argument here.
Hold on. Other people want to get in. Other people want to get in, and also I'm driving, and there's when I go through the mountains here, I might lose a little connection. So I'll try to, but I might pull back a little just because I don't want to have you guys hear roboting. But so why? Just real quick, snooze on a flat plane with a circle around you. You said 30 miles radius. Let's call it for that. Why would that not be the horizon on a planar Earth? If you're seeing the extent of the 30-mile around you on a planar Earth, and then beyond where you can see is, where the ground and sky meet, meaning the ground and sky meet, you can't see anything beyond that. Why would that not be the horizon on a planar Earth?
Because if you lay the hula hoop down, there is nothing stopping you from looking further than the hula hoop is, because the baseline is flat. You're on top of the baseline. You have a specific angle to the hula hoop. But if you reduce the angle a little bit, you will look further than the hula hoop. The only thing that limits or could limit you is the opacity of the air, which means like it fades out. There is no hard corner or hard like border. When the opacity increases due to particles in the air and so on, it's fading away. Like it gets bluer until you can't see anything anymore. This is not a sharp line.
Is that your flat Earth model that you're proposing?
No, this is reality. You see that every day, if you see opacity of air, you see it's fading away. There is no sharp point where you stop seeing something unless you see the horizon.
Octavio.
Right.
And what you're trying to do with your hula hoop is like trying to say that it's not a curvature at that edge. It's basically the horizon edge. But you forget the lateral curvature that you get from the center of your viewpoint towards the edge, which is also curved, not just a curvature in the circle. So how do you explain that lateral curvature?
Oh, we love this two globers role-playing with each other. Which one of you globers can actually properly represent the flat Earth idea of observations?
I'm not talking about the reality observation.
It's not very tough, globers.
In reality,
You've got a limited range of vision per perspective. The higher up you go, the more further out you could see. The bottoming out effect is explained by light bending up. So like when you're at the ground level and you see a boat fucking cut in half, it's because that boat's light is curving up and over your eye. If you go higher and higher, you will experience those light rays and see it. That's the flat Earth. That's the flat Earth explanation.
Okay, what does that have to do with the lateral curvature that we observe in reality?
Because it's about you fucking globers not being able to understand that flat Earth isn't the fucking glob, and there's
okay. Well, I'm not talking about the glob
more research
or the
and knowledge you got to do.
There
is more research and knowledge you got to do on your end as a globber
you not
before.
Listening to what I'm saying?
Yeah, interrupt me, bud. Interrupt me. Good one.
Are you not listening to
what
I'm saying?
You guys both stop? Can you guys both stop? Can we have a cohesive conversation? Octavio, go, Blob, Buster, please stop. Please stop. Okay, don't.
Okay, so
please,
Octavio, I'm talking about a specific observation that we make in reality. It doesn't have to do with the model.
Can you hear me?
I'm not talking about the globe model or the flat model. I'm talking about when we go up in the sky in reality and we look at our hula hoop circle horizon, the middle of that towards the edge also curves laterally.
Bro, respectfully, if all you're going to do is repeat what the glober model is and observations on the globe, just go on mute. There's plenty of people in here that can see things from both sides. You're just repeating your belief system.
You said that you had an explanation for the flat Earth model of this
Yeah,
flat
can you
globe
steel man
curvature.
it?
What is
Can
it?
you?
What is it?
Storm, can you
I
hear
would
me?
love to hear you steel.
Please stop.
Gio,
Guy's
Gio,
drunk.
you're kind of cutting out.
Yeah, I know. I said I might be, but this is going off the rails because this Octavio guy is gaper yelling. All right. So, anyways, let me respond to that. First of all, I don't know what Snooze said. Snooze, if you want to repeat your point, I didn't quite get because we had left it when I was talking about why would the circle of a hula hoop, why would that not be the horizon on a planar Earth? Because I'm describing that would be the horizon. The horizon is where the ground and the sky meet on an let's just say for the sake of the conversation, on an infinite plane. You would have an infinite plane Earth, and let's say you can see you give the example of 30 miles. Let's say 30 miles. You're seeing in a 30-mile radius hula hoop around you because that's the extent of the land that you can see based on the conditions, the viewability, visibility, etc. So that 30-mile radius is your horizon. So where the ground meets the sky at 30 miles all around you would be the horizon. So I don't that was the point I was making, and you were trying to refute that it wouldn't be, and you were saying like opacity.
No.
So you'd have to re-describe that. But secondly, Storm, what you were saying, I described very clearly. I said on a planar Earth, you'd have a circle around you like a flat plane hula hoop of the limited how far you can see. On a globe Earth, I can't let him talk without interrupting. Go on mute as well, so I can respond. On a globe Earth, you also would have a hula hoop, a flat circle, and when you're up above a globe, you're looking all around you, and that all those points on the horizon on a globe Earth are all coplanar. What I said, and you must not have been listening, I specifically said there would be a difference from your to the horizon. There would allegedly be a curvature, a dropping effect or a humping effect, however you want to call it, from your feet to the horizon. I clearly stated that. So if you're trying to rebut that point, that wasn't part of it, meaning that there would be curvature on a globe from your feet to the horizon. That would have to be established, but that's not what's being discussed. We're just referencing the horizon, and Icy Spins thinks that it looked curved. That's what was being addressed, not the from your feet to the horizon.
So maybe I just briefly respond first. The thing is, if you call something, or if you invoke something like limited vision or so, I have never seen any point in nature where you basically just have a hard stop, like someone is going away and suddenly blip, I can't see that person anymore or so. Like either you have it because you have haze in the air or you have fog or so. Something is like, as the distance increases, the gradients of opacity or invisibility increases.
You're
Same
straw
with
manning. You're
light,
straw
or
manning it again.
same with light or so. I'm talking about reality. If you have, for example, a flashlight and someone is in the spot of the flashlight and goes away and away and away, that person gets darker, 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 and at some point you can't figure out where that person is anymore because it's so dark. But this is a gradient, so there is no hard cut or so where you stop seeing something. And what we stop see something on the horizon is not forwards, backwards. We don't stop see something that is just at the horizon, and if the ship goes further, it stops seeing. And so we stop see the ship. We see stuff.
Can I back you up
stop
on this,
down.
Snooze? Can I
What?
back you up on this? Yeah, I just want to back you up on this little part here because the thing is, the horizon is not a location. It never is a location or a spot that you can be at. Do you understand? The horizon is just as far as you can see at that moment.
No.
Because
No, I can see stuff. I can
the
definitely
definite
100%, Rob. I can 100% see stuff that is located behind the horizon, because I can see when it is roughly at the horizon. I know that the horizon is basically an area or a range or so from front to back.
not a
It's not
location.
just a point.
Not
But
a
the thing is, in the
location.
ship,
So you
can
haven't
wait a
refuted what I
second,
said.
Rob, wait a second, breathe. I'm done soon, then you can talk. So you can identify when a ship is
Maybe
at the
address what I
horizon
said then.
you basically cannot see any water behind it. You just see that it's at the horizon line. But then the ship continues going further, which means I can see it behind the horizon. I can see stuff that is further away than the horizon area where we stop seeing the ground. So the ground is invisible from that point, but it's not a limited range. We can see mountains that are behind the horizon and so on. So it is not front to back distance limitation. It cannot be.
It's your ground position limitation at that point. Yes. You motherfuckers all think that you look up in the sky and you all of a sudden can see forever. It's fucking
Yeah, that's not
ridiculous.
nice. Well, what's the sun? Is the sun physical?
Yeah, you tell me what the sun is, smart guy.
It's
You
at
got
least
all the
equal
answers.
to the horizon when it goes down.
Well, Rob, on the horizon question, like I think Snooze made a good point. I posted a picture at 46 after.
Yeah,
so
but you
can
guys
see...
are all ignoring my point.
Okay, so you're just going to interrupt me? I'm not. This your
You're
point
all
was,
ignoring my point.
Let me repeat your point so then you won't feel the need to interrupt me. Your point was that there's no one place on Earth where there's a horizon. It's just every person looks out and there's a limit to their vision. There's a point at which their vision prevents them from seeing further, seeing
Resolving. Yes.
Resolving. Yes.
Yeah, you're getting there. You're getting there.
Right. Now, the question is, why is it that I can see things beyond that point and resolve those just fine?
Because they're large enough for you to resolve. Yes.
Okay. I posted a picture. I posted a video at 5:46. So 46 after the hour, 2 minutes ago.
But are you going to address my point yet?
I am. Well, my like, if I was to address the point, I would say that's not like, it's not about, you can always resolve the ocean, right? It's a big thing. You don't like suddenly stop seeing it.
How far can you resolve the ocean?
And I'm going to show you a picture of a boat where I can resolve the tiny windows on the top part, but I can't, for some reason, I can't resolve the much larger lifeboats at the bottom.
Yeah.
Because why that's the case.
There's particles, right? You're one of those particle guys. There's particles of gas between you and that boat way out in the distance, right? And they cause what they call turbidity in the air. No, I'm not watching your video.
Are you going to watch it?
You need me to watch your video?
I mean, it would help so you can see.
To address my point?
I'll watch your video.
Well, I mean, this is kind of branched off. This is hold on.
Doesn't address my point. But yeah,
all right, this has hold on. Yeah, this has branched off a little bit from the circle, the hula hoop kind of thing, but that's fine because I mean, it does blend into like what is the horizon and so on. But I mean, Rob wanted his point addressed, and then I mean, I don't know if the hula hoop thing, because on the globe side, somebody would have to be like, you know what, actually, like this is what Zanuck has done, for example. He said, you know what, you guys are right, because Jeremy and I and others have been talking about this like more. I mean, we've talked about it for years, but I guess more so in the last few months and so on. And Zanuck has agreed, like, yeah, if you're seeing left to right curvature on a globe, that isn't actually necessarily the curve of the globe. You're seeing a circle around you. And in comparison of coplanar points, is if you're just referencing the horizon. Now, on a planar Earth, it is a different description because you have something going on where you're seeing in a circle on a planar surface, then there would have to be like a limit of some sort. And then you guys are getting into like, okay, well, then what is the nature of this limit? And so on. And there is a cutoff point where the ground meets the sky. And yes, you can see like if you have a boat that's like 30 feet tall, when it goes past that limit of the ground, yeah, you'll see the top part of it because that's part of the sky layer of the ground sky connection, but the ground sky meeting point. But if it gets past that, the limit of the ground of how far you can see of the ground, you won't be able to resolve the bottom of it, the bottom 5 feet, 10 feet, 15 feet, because it is past that point on the ground where the sky meets the ground. But if the mast is 30 feet tall, that's essentially, in terms of perspective, that's part of the sky layer, even though it's not the sky, but it's part of the sky layer because you have ground and sky. And if you have a thing that's 30 feet above it, that's why you can see it past the limit of the ground. So the limit of the ground might be 3 miles on that day, but if you can see the boat at 3.5 miles, you're not going to see the bottom of it because the ground layer and everything right above the ground is already done for. That's a limit. And then the rest is sky layer. So there's a reason why that occurs.
Gio gets it.
Finky, can I bridge this for you and Rob real quick? Thank you, Gio, by the way. So Finky, you're talking about your observation at 46 after the hour, right? The cruise ship?
Yes.
Okay, so Rob, what he's asking you is and tell me if I'm wrong, but like, can you explain why that cruise ship is missing part of it underneath? I don't know that the geo explanation about where you're talking about the hula hoop. I know that it applies to this, right, to some degree, but the fact is that we're just asking for an explanation as to why this obviously huge thing that's not like a little motorboat out in the ocean that can clearly have a crisp horizon doing waves in front of it. Why is it that a significant portion of that cruise ship is missing? Something like
It's just
that,
easy.
Finky?
It's sinking.
He literally just explained to me.
Those are pretty excited waves.
Well, wait, I want to hear Rob's. If Rob is ready for an explanation, I wanted to afford him that opportunity because he was going back and forth with Finky. But Finky, is that a good generalization, or do I leave anything out, or is that where you're at?
No, it's perfect.
Okay. Do you have something to say about that, Rob?
Yeah, sorry. I was just watching. I was trying to watch his video. I wasn't really listening at the last little bit there. I was trying to watch the video. Can you give me just two? It's a 1 minute video, right? I just want to rewatch it again, and then I wanted to have a comment afterwards. Thank you.
Yeah, no problem. Fundy, you were saying something, I think.
Few comments on the conversation. I was just on YouTube. I went back 20 minutes and played it on 3 times speed to get caught up on the current state of the conversation. As far as the video that was just referenced, I don't know how tall. I don't know the height of the camera lens here, but the fact that there's waves obviously is going to be an obstruction. Now, I don't think that's the only factor going on to this. Obscuring the bottom of the boat to the degree it apparently looks to. I don't think that's the only factor, but of course that's one factor. And just to touch on, just to go back to the previous one before that one was brought up, here's a photograph. Here's some underwater photography, right? And you can see that there is a horizon if you look at live stream one text. Oh, shoot. You know what? I got to try. It doesn't like me uploading photos on Wi-Fi. Here you go. It should work this time now that I'm on cellular data.
Got it.
There you go. Live stream one text. Here's some underwater photography, right? You can see that there is a horizon where the floor tapers out and meets the sky, you could say, of the domain of Poseidon here. And obviously this is the exact same effect which is going on in these photos of on dry land, right? What do you call it? Attenuation of light through a medium.
Sure. Do you know where this photo was taken?
I don't know where any of the 3 photos I just posted were taken from. I mean, underwater and on dry land. The second 2.
I was curious about the underwater. I mean, clearly this underwater is what, like 30 feet, maybe 50 feet tops.
Sure. There's something really interesting I want to point out about it, though. You see where it appears to be like really dark, maybe like 50, 60 feet away from where the camera is placed underwater. You see where it appears to be just like an abyss of darkness. Do you understand that if the cameraman traveled 60 feet forward to what appears from his perspective right there, which is shrouded in darkness, he would have a circle of, there'd be a radius of light around him just as illuminated as the one that he's currently in this photo, surrounded by. That area over there isn't actually dark. If you went over 60 feet forward or in any direction, it would appear to be just as illuminated as he would have a circle of vision around
That's
him.
why it would be like, let me point out a couple things about this photograph, right? Like you can look through the ripples of the waves, right? Where look at the guy's fins, right? And then pan like left and go up a little. You can see that there is something towering there, right? Like it looks like there's an obstruction outside of the water. And then same thing on the right, right? It looks like there are land features that are causing this sort of circular light to bleed in. Would you agree with me?
I wouldn't agree at all. I can't see them, and I also don't think this horizon or circle of light is based on, you know, geographical elements or something. I can pull up countless videos, and it's just the same case with all underwater photography, that you get this emphasized more so underwater than on dry land, looking through a different medium of air. You get a circle of basically illuminated land around you in a pretty even radius spanning out from your
I
center
would
point.
agree. I think I would agree that I mean, light does
This is
not
exactly
travel
what
well.
happens when you
Light
take,
does not travel
mountaintop
well underwater.
photography.
And
It's just
I'll
attenuation
let
of light. It's
Pinky
pretty simple.
I'm
Pinky
trying
can
to
have my
agree with you,
response.
but
Go ahead.
no, I was just gonna say I think this probably represents what would happen underwater. I'm curious how you think that how that transports to what we were talking about.
It was the previous topic before you were talking about the boat. Gio was
Another
talking
thing,
about the
can I point out
Gio
one
was
more
talking
like
about
thing
if
the
for
you were to
this?
hula
draw,
hoop
let me make one point
horizon
real quick.
around you,
If I can
caused
if I can
by
manage
your
to get it
limit
in.
of vision looking through a medium. And I'm just highlighting that this underwater photography with a horizon 60 feet away is the exact same effect which causes the horizon in the two next pictures I posted from mountaintops, where
Okay.
you could see
I
further,
got it. I think I
but
got it. I
just
think
like
I
the
got your
water
point.
is limiting your vision,
Yeah, I think I got your point.
the air. So
I
that's
got
how
your point.
mediums work.
Okay, so I think the analogy though for the boat picture would be if we saw this image right here, and you can clearly see that like a light's not
Yeah,
going
it's not
past
related
that,
to the boat.
and then beyond, just somewhere out there in the blackness, halfway obscured, we could just see something. Right? Then you might say, well, that's weird. Why did it get black? I can't see anything. And then I just randomly, I can see this thing beyond that black spot. Because that's kind of the question with the ship is why is it we have a limit of vision like this, but then we also can see things beyond it? Because the bottom two pictures you posted are that you like
Because
wherever
you
the
ignored
end of that
Gio's
is, wherever
response.
almost done. The like where that fog, you can see the fog or whatever. I've not seen anything past that. That's the end of it, right?
So you didn't understand Gio's response to that then? Or you're just ignoring it? One of the two.
I'm not ignoring it, so I probably just don't. Maybe I don't understand it.
Vertical objects are gonna obviously be more apparent through this light attenuation mediums effect thing than the ground itself. 10 feet horizontal is harder to see than 10 feet vertical of the surface of an object. Takes up more of an angular, takes up more angular degrees in your vision, and it's also not traveling further away from you, increasing the amount of medium you have to look through.
Yeah, but if it's bigger and I can see it better, then I should be able to see all of it, right?
Yeah, I mean, you got to reference back to the first point, the amount of degrees of angle it takes up in your vision and how much you're looking through.
Yeah, I don't. That's
It's also
my
important
issue. I
not
think
to
with
think
what
that's the
Gio
only
said.
thing going on. It's a whole multitude of effects all simultaneously piled on top of each other.
Yeah. So what other effects are causing that, or could be
Why
causing
don't you
that?
know? Why don't you know? I don't want to go through this again with anyone, really. If you don't know,
Checkmate.
willful ignorance, in my opinion.
Yep.
All right, that's fair. We don't have to go through it.
Yeah, what can I say? This has been as much pleasure as I've had all day in the last 3 hours. I think I'm gonna bounce. It's been a pleasure. Thank you guys. Thanks for the conversation.
All right, later.
All right, see ya.
I spin.
Take care. See.
All right, I'm out too. Bye, guys.
Well, it's good to hear you in the VC Fundy. Maybe I'll ask you a quick question, unless you have something more interesting, which you probably will. I asked the Globe team if. Thank you. I asked the Globe team if the government was hiding some sort of barrier or firmament, whether it's close or far, would they allow the civilian population to find it? And I think the majority of the Globers said yes. But what do you think?
Oh, I mean, if we all woke up with amnesia on a farm that's like a million acres wide and has fresh water and animals for us to sustain ourselves off of, a lot of people are just gonna like build a home, build a log cabin, and eat the plants and crops and livestock and never explore the edges. But as soon as one crazy motherfucker says, I'm just gonna. I know everything I need is right here, but I'm gonna see what happens if I just pick a direction and walk that way. If he ran to a fence and then came back and said, "Hey guys, I have some serious news to report to you. Um, I ran into a wall that we're surrounded by, and I actually took a whole lap tracing the wall around us. We're in a pen." That would cause such upheaval, and if there was anyone trying to prevent people from knowing that, man, they'd go to any extent if their goal was to prevent complete like chaos and upheaval of the order established there. I mean, like 90% of people would be very disturbed to find out that they're in a pen, because the natural human
I think
instinct
that's a
would be
great
like
analogy.
to seek freedom. And like the majority of people would want to know, can we break through this wall? Holy shit, there's a fence around us. What's on the other side? That would stir up quite a frenzy.
Yeah, it is interesting, Eden. I heard you ask this question earlier. It is interesting, like just the idea, complete hypothetical, that there is some kind of firmament with a globe. Would the powers that be allow the common man to go, like, get to it? And like Fundy was saying, because people would want to, they would want to. I mean, there's the seeking for exploring, but people already want to launch up high altitude rockets and stuff, like some of the amateur rocketry and stuff that people have done. And I think you mentioned one of them that was you said 144 kilometers. But yeah, I mean, whatever the absolute maximum that a civilian has been able to launch something, what if what if there is something that occurs at 1,000 kilometers and they've only gone to 144, and everything beyond that is sort of government regulated and so on, so that already, I mean, I'm not saying there is a firmament on a globe, but I'm just saying that I think the pretty clear answer would be that you have to have clearance to go, quote unquote, into outer space. Like, you can't just make a rocket in your backyard and go to outer space. So there already are limits to how high you can go up. And if there was some kind of either barrier or a superfluid or something else going on, an electromagnetic field or just anything else, that already would be kind of off limits to civilians, unless somebody wants to spend all the money to try to make their own rocket company and try to get all the clearances and all the permits and stuff, which would be interesting to test that. But as far as we know, no one's really pushed that boundary yet.
Thank you, Gio. Yeah, that's what I'd love to see. I'd love us to maybe pressure Elon Musk to maybe create the first uncut video from Earth to space. Or we could have a race, first video to 1,000 miles, something like that.
I'd love to see just an undercover guy just go in and just be like, "Oh yeah, we're just gonna send it straight up, man. We're just gonna send something, our own probe to Mars or some shit." I guarantee you, before it got off, they'd be like, yeah, you can't program that shit to go straight up because it's not gonna get out." Dude, things can't get out. There's a ceiling, man. There's no freaking way. And then they'd be busted. You're like, it's gonna
Yeah,
run
we
into a
should send in.
freaking feeling.
Yeah, we should send in James O'Keefe. You know that guy who does the undercovers? You should go in to NASA, SpaceX. But yeah, I agree with you. If they were about to have a project, let's say if they granted us all the authorization required, it would be interesting if they had to sabotage somehow. Sabotage the experiment or observation.
Do you know offhand, like, not anything run by the government or the space agencies, but do you know, Eden? I just don't know if I know you mentioned the 144 kilometers, but what is the highest any civilian has ever launched anything? Do you know?
Yeah, that
Or
is
does anyone else
Aftershock
know?
2. I think it's Aftershock 2, 2024.
That's
at 140. Yeah.
Is it
What
not
was
Felix
the
Baumgartner?
what about the
I mean,
Mage
if you
2?
want to consider that civilian, it's Red Bull, so it's not quite civilian.
What about the Mage 2 weather balloon thing? Just a sec, I'll see if I can find it.
I don't know why someone wouldn't want to launch one of those Felix Baumgartner weather balloon type, buoyant objects, but have the payload be a go fast rocket to launch once it's reached its maximum altitude. It's like, how have those technologies not been combined yet? Float the rocket as high as you can, then launch the rocket. Apparently, we've got some garlic bread put on a weather balloon. We got footers of that, right? Instead of garlic bread, why not a rocket? Small one.
Well, the U.S. government were doing that. Remember, I think the X rocket they would attach to a military plane when they got to high altitude. They would get that rocket going and maybe have someone pilot it from high altitude. I'm sure you guys have seen that. But yeah, funny. That's why you would make it in the military. You're a smart man. Good thinking.
It'd be extremely easy. I mean, they put a whole Tesla Roadster in space, including the engine and the stock tires. Oh my god. So what the hell's the problem about getting something, I mean, I know they used a rocket for that, but it's just, I don't know. So dumb.
Okay, it looks like the Mage 2 weather balloon that they sent up went to about 38,000 feet before the balloon popped.
The highest weather balloons are going up to about 180,000 feet max.
Yeah, this was just like a private one. This was like a private citizen one.
How many kilometers is that? And thank you.
38,000. So 3.8.
That's just like airline flight height. This is normal airline flight, so that's not. I'm surprised.
Yeah, you said that's not a private citizen.
No, the highest right now, the record is 144 kilometers above sea level, if I'm not mistaken.
180,000 feet is 54 kilometers. There's this important milestone that everyone has to consider. It's at 100 kilometers. there's this 100-kilometer mark. It's like 380 or almost 400,000 feet. Okay, so let's think 400,000 feet. Okay, the highest military balloons are going up to 180,000 feet. So I'm just sharing some info. I mean, this is for y'all's future considerations. So apparently the highest balloons are going up 180,000 feet, and this so-called edge of space is at 400,000 feet. Right around this mark, especially when their shit is coming into the earth from wherever they claim to be, at around 100 kilometers, typically around 90 or 80, that's when, if you watch the videos of them coming into Earth, like the full video they have from space to ground, they go through this orange like let's start primitive. If you watch the video, they're coming to Earth. A significant visual milestone is they go through this, the whole screen turns orange. And this only happens at a particular point, or is around the Kármán line region. This is the region where the rockets allegedly position themselves. They apparently have heat shields. They have these custom engineered 12 by 12 blocks of custom engineered material that quickly dissipates heat. And they have it on one side of the rocket. If you look at some of these rockets that allegedly go really far, they've got like half of their bodies is like black, or like half of their bodies is like this. They have this heat shield on, and that heat shield is for when they're coming in. They position themselves where they're like bodies belly flopping into the atmosphere of the Earth. They allege that due to the speeds that they're coming in, it just, at around 100 kilometers to 80 kilometers, the whole screen turns orange. Sparks, like these weird sparks, come off the rockets, and they're like riding the atmosphere and using the atmosphere as like a brake. And while they're coming in, that's when at that point, the whole screen turns orange. The heat shields start heating up. The heat shields turn they start glowing orange. And then they come in around 60, around 70, 60, 50. Then all of a sudden you see the Earth in its like atmosphere, like you're in it. And
So
then they land.
what's up with the all those like heat shields and all that. So they got like special ceramics and all this stuff. The stuff they used to put on the shuttle for when it hit the atmo, and it would heat up and they'd lose tile. But now they're just like turning rockets around backwards and then flying them cylinder side down, like the opened end, like not even like air, like not even a round end. They're just flying these like boosters backwards at like Mach 5 or some shit. I think it's like 7,500 miles an hour or some shit. They say
No,
these things are coming in.
they're faking it. What they're doing is they launch, they go really high up, and then they go further away. And from your perspective, it looks like it's going down around the globe, but they're just really going like out there somewhere.
Yeah, exactly.
I'm just asking why they like the boosters, why they like, if they're really going to space and then are boosting the rocket up to space. I don't know at what point they let go. But why don't they need, all this shielding to come back down? Or do they just like come off way, way lower and they're
Well,
not
I
coming
mean,
in through the atmo?
that
I mean, I just want to
depends.
know their narrative. Like, where do they dump off, and why don't they need big heat shields? They just turn around and go, ass end first, open freaking like cylinder, whatever. It's not, it's not like the point of a missile. It's just flying ass first. I don't know. It's kind of interesting to think about that.
Locksmith, are you here? I'm just curious.
Yep. I'm
Oh,
here.
wow. I'm not sure. Wasn't that interesting where we asked for flat Earth evidence and then someone provided, well, they said sea cables. And then we asked about the details and they're like, I don't know.
Well, I wasn't here for that, but
Oh, okay.
that is funny.
Yeah.
So sea
And
cables were the evidence?
yeah, so someone presented, oh yeah, the somehow the sea cables in the south prove globe. So I'm like, all right, let's go through that. Let's get into the details. And he's like, okay, here's the source. And I'm like, okay, do you know the source? Who's the source? And he's like, oh, it's my close friend. I speak with him every day. And I'm asking, okay, since you speak with him every day, maybe you know, by being with him and you've discussed it, you've heard him out, you memorize it, or you at least maybe you know a rough version of it. Can you explain it to us? And he's like, no, I can't. I'm like, so here's your best friend or one of your really close friends, and you're not even listening to him.